Rohini Sengupta and I will be presenting Programming in C. I will be explaining all the concepts which are there in this chapter, which will include 5 chapters in total. I will be explaining each chapter and each topic in detail. So, let's start. So, this is the table of contents which we have in our syllabus for the second semester of the first year CSE, and the chapters include programming concepts, which is the first chapter, which will include the basic concepts, arrays and strings, the second chapter. The third chapter will be functions, the fourth chapter is structures and unions, and the fifth is finally the last one, that is pointers. Now let's start with the first chapter. The first chapter is programming concepts. So in this chapter, it is a basic chapter to build up the concepts of the C language, which will include the following topics, including the history of C, compiler and interpreter, algorithm and flowcharts, constants and variables, keywords and data types, operators and expressions, input and output operations, preprocessor and macros, C decision making, branching and looping statements. So all these come under the basics of programming concepts. So we will just take a look and all of them and understand them with the help of programs. Okay, let's start. So, coming to the history of C language. C language is one of the actually most oldest programming language which is still used today. So it is quite important. It is a little difficult compared to the newer programming language. Difficult to understand because you kind of need to write down everything. But it is very much related to the hardware. So it will be interesting to learn. So the C language was developed by Dennis Ritchie at Bell Labs in early 1970s, evolved from the B language, and it is also known for its efficiency, portability and the ability to interface with hardware. Initially, it was used to write the Unix operating system, now which is actually not used anymore, but still. C is a procedural oriented programming language that uses top-down approach with functions and variables. So, what is a procedure-oriented programming language? Procedure-oriented programming language, there's a difference between a procedure-oriented programming language and object-oriented programming language. Like in the newer programming languages, which like Java, which is completely object-oriented, and Python, which is object-oriented and procedure-oriented, which Python acts as both. So C, whereas it is a completely procedure-oriented programming language. We will take a look now. So now we come to the compiler and interpreter. We will learn what these two are and I will explain the difference between them. A compiler translates the entire source code of a program into machine code before execution, producing a standalone executable file. An interpreter, on the other hand, translates and executes the code line by line during execution without creating separate executables in C programming mainly. So the main difference between compiler and interpreter is that the compiler converts the entire code when the whole program code is written from the start till the beginning. If it is correct, the code will be translated to an object file. Okay, after it is translated to an object file, it will be read by the compiler and the high level language will be converted to machine level language. The source code will be converted into object code and it will give us an output. So when the entire code is being considered and it is converted into object code, that work is done by the compiler. Whereas in an interpreter, it translates code line by line. So every line of the code, it will keep on checking. So compilation and interpretation both are similar but not exactly the same. Compilation takes the entire program and converts it into an object file. So source code is being converted to object code. So what is source code? Again, source code is high level language which we write our programming language in. It is basically the English level English language. So English language is not understood by the computer. How will the computer understand it? Why? Because computer understands it only zeros and ones, which is the machine language. So it needs to be converted. So that the whole thing, when it is converted at once, that is done with the help of a compiler, when the whole high level language is converted to machine level language. Interpreter does the same thing. It converts the high level language to machine level language, but it converts it line by line. Every line it keeps on checking, like this is incorrect or this is correct. The compilation and interpretation process come side by side, but it is not exactly the same. But yeah, in interpretation we don't have to produce an object file, since every line is checked. So this compilation and interpretation come together while we execute a program. Moving on, we have algorithms and flowchart. An algorithm is basically a step-by-step method where we write down the process, like which is taking as input, which we are taking as output, what is going to happen, which we basically write it down in English language. That is an algorithm. You just write 1, start, 2, take input. So just like that, you just write it down in English language. That is algorithm. And a flowchart is the same thing as an algorithm, just that it is a visual representation. So, and it helps understand the syntax or the logic better. Okay, so both of them are basically the same thing, which are required and which are advised to do before writing a code, so that the users can understand while reading a code. We cannot directly read a code and understand of what is written in it, because until and unless we know the basics concepts of programming languages. So when it is written in English language, step by step, that is called an algorithm. And when it is shown in as a visual representation, as a picture, showing the data flow, that is a flowchart. So algorithm is a step-by-step method to solve a problem, written in plain English language, has input, process and output. And flowchart is a visual representation of an algorithm, uses symbols to show steps, and flow makes logic easier to understand. Now let's take a look at the different shapes which are showed in shapes and symbols which are used in a flowchart. So the first comes the oval symbol, which is basically represent the starting point or ending point of a flowchart. Here it is one example of the flowchart is given. This is the starting, this is the oval shape, it is the starting and the end. And second is the arrows. Arrows show the flow of information from where to where the information is traveling. So yeah, arrows are of course very important, just like labeling in diagrams. So, and this is the input and output. A parallelogram signifies an input and output to display or to take an input from the user and display the output. And next we come to the rectangle. Rectangle shows process or the calculation part. All kinds of technical things are shown with the help of rectangle. So over here, this process part, like calculation, taking any kind of addition, subtraction, anything, it is done with the help of rectangle. And finally we come to decision making. So what choice do we have, what kind of decisions we need to take, that the diamond helps to decide. If it is true, one process is executed. If it is false, another process is executed. So that is also depicted by the help of arrows. Moving on. Now we have C tokens. So C tokens are basically the fundamental particles of programming language, the fundamental units. Just like cell is the fundamental unit of the human body or of all living organisms. Cell is the fundamental unit. Everything starts from the cell. So of course cell is again divided into a lot of parts, but let's not go into it. So C tokens are basically the fundamental units with which a programming language is developed. It is actually similar to all the programming languages, since if you learn it, It will help you understand better. So C tokens are the smallest units of a particular program. The tokens are the basic building blocks of a program. So these, without the help of these, we cannot write a program. It is a very fundamental and basic units of making a programming language. They include keywords, identifiers, constants, strings, operators, and special symbols. We will be learning each of them in detail. So let's move on. First, we have C identifiers. Okay, in C, an identifier is a name which is used to identify variables, functions, structures, or any other user defined element. It is essentially a label which is used in code so as to you can refer to data or functions by name. So basically, when you call someone by their name, like my name is Rohini, you call me by my name and then I answer you. So you just can't call me, here you girl, come on. So you can't do that, right? Because I have a particular name. So since when you need to call me, you need to use my name. So whenever we use any kind of element in a programming language, we need to name them. So basically, to name the variables, we have a lot of rules. Variables are also called as identifiers. Okay, so it's basically the names given to the variables, or it can be structures, functions, arrays, anything, or as well as functions. So there are certain rules. Let's take a look at the rules of naming an identifier. It can contain letters, capital letters from A to Z, or small letters from A to Z, digits 0 to 9, underscore. But the digit should not come at the beginning of the variable name or identifier name. Okay, it must begin with a letter or an underscore. Underscore is the only special symbol which is allowed for naming an identifier in C. Okay, so this is a valid identifier name. Underscore template number 1, this is valid, but you can't write as one number because 1 is a digit and you cannot start with a digit. So yeah, this one you cannot start with a digit. This is wrong. Number 3, cannot use C reserved keywords like int, float, return, etc. You cannot use any kinds of reserved keywords because these already have a predefined meaning in C. They have a specific purpose. Certain tasks are assigned to these words which are classified into a lot of types, but these are reserved words. You cannot use it. Instead of them, you can use any word as an identifier. No special characters is allowed, like dollar sign, percentage. Percentage is allowed, but it is used for a specific, it is used as an operator as well as it is used as a format specifier. We'll take a look at it and we'll understand later. So instead of that, comma, exclamation mark, question mark, nothing is allowed. It is case sensitive. Of course, capital letters and small letters are treated as different identifiers. So value is a different identifier, this value is a different identifier, and this capital value is again a different identifier. So coming to the last one, the no length limit in C, in standard C, but some compilers may impose a practical limit. Moving on, we have keywords. Keywords, this is basically like the dictionary of a programming, the C language. So these are the words which are present in the dictionary. Why? Because they already have a predefined meaning. They have certain functions which is already assigned to them. You cannot use them because every one of them has a specific function. We will be learning most of them in this PPT, in this video. Actually, we will be learning most of them, but these are basically the dictionary of words which is present in C language. So keywords are the reserved words that have special meaning to the compiler. They are predefined and cannot be used as identifiers, that is variable names, function names, etc. We cannot use them at all. Okay, why? Because they have a specific meaning. We will learn all of them. So they include auto, double, int, struct, while, static, void, break, else, long, switch, continue, if, goto, case, enum, register, type def, size of, volatile, char, extern, return, union, default, signed, const, float, short, do, unsigned, for. So all of these have specific meanings. We will come to them, learn them individually in the coming slides. Now we have constants. Constants are basically fixed values which are already there in a program. So you cannot change them. So constants are fixed values used in a C program. These values do not change during the execution of a program. So constants are first divided into two types, integer constants and real constants. So, and coming to the integer constants, it is again divided into two types, character constant and integer constants. Character constants includes strings. So in C language we don't have a particular data type as string, or we don't have strings in general. An array of characters is considered as a string. Okay, so coming to integers divided again into two types, int and long. So basically these two perform the same function, only the memory reserved is much more. So int is divided into signed int and unsigned int. Long is again divided into signed int, long int, unsigned long int. This comes to the all integer part is over. Now the real part or the fractional part. So there are two types of data types, float and double. Double has again two categories, double and long double. So again this will be of more storage. So these are all the constants. Moving on, we have variables. Okay, variables are just the same thing, it has the same meaning as we use it in maths as well. So a variable in maths is basically what its value can be changed. Its value can be varied from program to program. Okay, it is not a fixed value, it keeps changing. So just like that, x and y are variables in maths, the same way it is used here as well. It is a named storage location in the memory that holds data which can be changed during the program execution. So it is a named memory storage, named storage location in the memory. We need to remember the definition. This thing can come in the examination sometimes, and the rules for naming a variable is same as the rules for naming an identifier. Let's take a look again. It can include letters from capital A to Z, from small a to Z, digits, underscore, but digits can't be at the beginning, underscore can be at the beginning, must start with a letter or digit, yes, total, it cannot start with a number. Coming to the fifth one, cannot use keywords, we just did that right now. No special characters are allowed, like at the rate, dollar, hash, etc. Hash is used for something else, which we will come up later. It is used for preprocessors and macros. We'll learn that later. It is case sensitive, of course. Let's move on. We have data types. So data types is one of the most important topics of this chapter. We will learn each one of them in details, and it is the most important concepts. So a data type defines the type of data in a variable can store. It tells the compiler how much memory to allocate and what operations can be performed on the data. So it's basically in general there are so much of data, right? There can be data offline, there can be data online. So now we're talking about only online data. So even in online data, it can include numbers, strings, a lot of things, right? So the data is a random way of telling that this contains data. So you have to tell the person what type of data it is, and you need to sort it accordingly. You need to arrange the data, and so since we need to arrange the data and sort it, there are different types of data, so we need to arrange them. And to represent those data, we have data types. So the data types in C include primary data types, derived data types, and user defined data types. Under primary data types, we have void, integral, and floating point. Okay? Under integral data type, we have integer and character. Again, coming to integer, it is of two types, signed and unsigned. Signed integer, these are int, short int, long int. All of these have basically the same function only, but the amount of storage which is each data type has, it varies. We will be learning about that in the next slide. Unsigned integer comes to unsigned int, unsigned short int, unsigned long int. So this is again varies in storage locations. Coming to character, we have char, signed character, unsigned character. Finally, coming to floating point, we have float double, long double, float, all of this. Now we will come to the next category, or we are done with primary data types. Now we'll come to the next category, that is derived data types, which will include arrays, functions, and pointers. We will learn each of them in details because we have specific chapters for each of them. User defined data types. User defined data types include structures, unions, and enum. This also we will learn in depth because it is there in each chapter. Let's move on. We have data types. This is basically the theory of what I said just now. It's a tabular arrangement for understanding and learning and writing in the exam. This is very useful. You just take a look at it, like primitive basic data types, which includes int, float, char, double. Stores fundamental data types like int age 20, char grade equals to a. This is the examples how it is used. Derived data types, array, pointer, function, reference, built using primary data types. Derived is what? So you're using the basic primary data types to build them for structured programming. Okay, so again this is the example. User defined, which are structured union, enum, type def, which created by programmers to define complex data models. So this is basically the tabular arrangement of the same thing. Now we have primitive data types. What are primitive data types? Primitive data types are the built-in data types or fundamental data types provided by C. These are already defined under C. Okay, we just need to take them and use them in our program, which already has a meaning. Everything is given. We don't have to specifically make them. When we make them, it comes under derived data types. It can be directly used to store simple values like numbers, characters, etc. So they include int, float, double, char. Int is for integer, float is for decimal numbers, double is for decimal numbers, that is double precision, and float is for single precision decimal numbers. And character is single characters. So these are the examples. Int age equals to 20, float pi equals to 3.14, and double temp equals to 98.6. So the difference between float and pi is the amount of the size limit, and float is used for 3.14. This is single precision. This is one digit. Two digits are there before the decimal point, and before the decimal point there is one digit, and here we have two digits before the decimal point. So that's the basic difference. But it's always safer to use double because you can use float also. It's safer to use double because sometimes you just work with a lot of data and you need to change it to double later on. So, and this table represents the size of each data type. So this, I think this has become the old standard. This is not currently used. Int is nowadays uses 4 bytes. Short int uses 2 bytes. This is correct. This is the data of the DOS platform. The Windows nowadays, the systems do not use this. Short int is used for 2 bytes. Long int is used for 8 bytes, not 4 anymore. Unsigned int is again 2 bytes. Unsigned long int is not 4 bytes. I think it is 8 bytes. I'll check and let you know. And these are the format specifiers. %d, %u for unsigned int. Unsigned values are mainly used as %u. We will learn format specifiers in details in the coming slides. Derived data types. So what are derived data types? Derived data types are types built from basic data types. They are used for grouping and manipulating multiple data values, accessing memory efficiency, and handling grouped data. Data type. Data type, that is array, collection of elements of the same type. Array is a collection of elements of the same type. We have to remember the definition. And structure is a group of variables of different types. So this is basically the opposite. Array and structure are two opposite things. And example is int marks within square brackets 5. 5 represents the size of the array. Int is the data type, marks is the array name, and 5 is the size of the array. And semicolon is the termination of the statement. Pointer. Pointer stores the memory address of another variable. So pointer is represented by the star symbol or the multiplication symbol. So int pointer equals to address of x. Address of x is this is the address of operator. Ampersand is used as address of operator. We will learn that in operators, but we use it as address of as well as an operator. It is used as a bitwise operator, bitwise and also it is used as logical operator when you use 2 ampersand. We will learn that in detail how it is used as an operator, but for now it is used to store the address of a particular variable. Functions. Functions is a block of code performing a task. Int add, int a, comma, int b. So int add is the function name, int is a data type or the return type of the function, and within parenthesis we have 2 arguments, that is argument list, parameter list consists of 2 arguments, that is int a and int b. Okay. Next we have structures. Group variables of different data types. Struct student, int id, char name with 20 size. So this is a structure. And union, we have all this, we have chapters based on all these topics, so we will be learning every one of them in detail. Union stores different data types in same memory. Structure and union are basically the same thing, but the structure has specific data. The memory address of a structure variables consists of a longer address, while union causes overlapping of the memory. So it is used, it has the same type of syntax, but the memory location is the only point of difference between a structure and a union. Enum, user defined list on a name integer constants. So enum day is Monday, Tuesday, Wednesday. Moving on, we have user defined data types in C. What are user defined data types? They are created by programmers to build complex structures, modeling real world entities and custom structures. So they include struct, union, enum, type def. We did struct, union, enum just before. I'm just reading through it. Structure is group of different data types. Union is a memory efficient version of structure. I just explained the difference right now. Set of named integer constants is enum, and type def gives a new name to the existing types. So type def is basically has the same usage as def in Python. So it is used to give a particular name to the existing types. When we use a structure, we can use type def struct student and then give all these, and then finally we can use another name to take access of the structure elements in the structure. So type def is very extensively used in data structures mainly. Moving on, we have operators. Now, what is an operator? An operator is a symbol that tells a compiler to perform a specific mathematical, logical or relational operation on variables or values. Operators help write efficient logic and perform operations on data. So operators is very important in C. This perform operations, all types of mathematical operations are performed by operators. So we will be learning each of them in very details. There are a lot of types of operators. So they include arithmetic operators, logical operators, relational operators, bitwise operators, assignment operators, and miscellaneous operators. So these are all the operators in C. We will learn each of them in detail, and we will learn a code also as well along with it. Arithmetic operators. Arithmetic operators include multiplication, division, remainder, modulus, addition and subtraction. Addition and subtraction we use it just as it is in the math. For multiplication we use star, for division we use slash, and for modulus we use a percentage. So modulus is basically finding the remainder of the two numbers, and division is basically finding the quotient of the two numbers. And these are the expressions. Moving on, we have logical operators, bitwise operators, and relational operators. Logical operators is a combination of relational operators and logical operators. So our logical operators include ampersand, which is a logical and, logical or, the two standing alone bar type of thing, which denotes a capacitor in capacitor in physics. That's not important. Logical not. So the example is for logical and, both the expressions should be true. 5 is less than 2 and 5 is greater than 3. 5 is not less than 2, that is wrong. 5 is greater than 3, only one particular statement is right, so and will display a result as false. For and, both the operations there should be at least two operations in and. We cannot use one operation for and, logical and both of them should be true in order to result as a true output. For logical or operator, any one of the expressions should be true so that it will return a true value. So 5 is greater than 3, it is one of the values are true, so it will return a result as true. Not is logical not. Whatever is plus, it will change into minus. Whatever is minus, it will change into plus. 0 will be converted to 1, 1 will be converted to 0. It will just make the opposite. Not. Bitwise operator. Bitwise operator is basically the same as logical operator. Only difference is logical and we have 2 ampersand. Bitwise operator, bitwise and we have 1 ampersand. So this is bitwise and, bitwise or, bitwise XOR, left shift and right shift. Left shift is used for shifting, this is for as +1 to the left, and right shift is used for shifting +1 to the right. It is used as well. Coming to the relational operators. Relational operators includes greater than, less than, greater than or equal to, less than or equal to, is equal to, not equal to. So these are used for checking conditions mainly. It is used for checking in if statements. All of these conditions, whenever a condition comes, a relational operator is used. So a logical operation is a combination of relational operator as well. Like two relational operations, our expressions are joined with the help of a logical operator. Here we can see that, right? So relational operator, these are the expressions and these are the values. Moving on, we have operator precedence. Operator precedence is a very important topic. It is basically the set of rules which determine the order in which the different operators in an expression are evaluated. When an expression has more than one operator, plus, minus, into, divide, operator precedence tells the computer which operation to perform first. Operator precedence helps avoid ambiguity in expressions and ensures that the program execute operations in the correct order. So when all the operators of same precedence come together, the compiler does not know which expression to perform first. So we need to know how the expressions are evaluated in operators. So it's basically like a set of rules which we need to follow to determine which operation we need to perform first. So it is basically like the BODMAS rule. Okay, right? BODMAS is what? What is the full form of BODMAS? Bracket of multiplication, addition, BODMAS, MAS. BOD, bracket of division, multiplication, addition, subtraction. So the BODMAS is a rule. So since bracket is considered first, then off. So just like that, we have a particular rule for solving operations in BODMAS. The operator precedence is again another set of rules which we need to follow. So this table, this chart shows all the operator precedence, how the operator expressions are considered. So this shows from highest order to the lowest order. The highest precedence is given to the brackets on top, and lowest precedence is given to the assignment operator, which is at the bottom. So the parenthesis or brackets or any type of bracket is considered from left to right. Okay. Unary operators like plus plus, minus minus. So plus plus, minus minus does not require only one operand. It does not require two operands, so it is not a binary operator. Anyway, so it is again expressed from right to left. We need to remember that as well. From where to where it is, the operation flow of operations are taken place. So arithmetic, mostly they are all from left to right except for unary operator, ternary operator and assignment operator. So arithmetic operators, shift operator, relational operator, bitwise operator, logical operator, all of them are considered from left to right. Okay, and this is the chart. You need to remember it in order. So since highest to the lowest. So in descending order we need to remember the order. So coming to the ternary operator or conditional operator, ternary operator is basically an if-else statement in reduced form. So in a shorter version. So that is also considered from right to left. We will do ternary operator condition in the next slides. So and in the end we have assignment operator again, which is calculated from right to left. Moving on, we have input and output in C. Now coming to input and output in C language. So what is input and what is output? Input is something which you get from the user, or the user enters a value that is taken as input. Okay, and output is something which is showed in the display screen or the console screen. The monitor, the result which we get after all calculation and everything is done, that is called the output. Okay, so input and output plays a vital role in C language, of course, because it is basically the fundamental blocks. Input is taken with the use of scanf function, which is defined under the stdio.h header file. So what is stdio.h header file? First we need to know that. And stdio.h is standard input output header file. It stands for standard input and output. So that file is like a library function. It is a file. What is the header file in C? A header file is like a library function. So what is a library function? A library function has a set of functions which are already predefined in that particular language. We can just use those language in our program to perform specific tasks. So again, what is a library function? To understand it better, we will take an example of a library, plain library. Okay, why do we go to the library? To access books, right? So any kind of books which we need to access from the library, we need to go to the library and find it, right? We need to, suppose we need physics books, we go to the library, look for engineering section, and then we have to see where is the physics section, and then we go to the physics section and take a particular book from there, and then we use it. And in our life, however we need it, we just use it, that particular book. So in the same way, it is like a library consisting of all the books, just like a library consists of all the books, which is of various types and various which shows various functions. It is a similar way. This is a header file is like a library function which stores a collection of functions which perform different tasks. We just call the function and use the function from that particular library. Okay, and in our program, so we need to include it in the program, that this file, this header file, we are taking it. Okay, so normally under standard input and output header file, most of the functions are defined, But if we take dynamic input, dynamic memory allocation, we need to use a standard std.lib header file. For math functions, we need to include math.h header file. For string functions, we need to use string.h. So we will learn that in detail. That is basically called the preprocessor units. We need to mention hash include stdio.h. So preprocessors, we will understand it later. And now let's come back to input and output. So the syntax of scanf is, first we need to write scanf. Within parenthesis, we have to first write the format specifiers within double quotes. Okay, so the format specifiers are the type of specifiers which tell us what type of data we are taking as input. So we will learn format specifier in the next slide. It is something very important. We will learn it. But for now, let's focus on the syntax of the format for scanf. So after that, we will give a comma and then followed by the address of operator, which is the ampersand, variable 1, comma, variable 2, any kind. So ampersand variable 2. So ampersand is the address of the variable, is used as an address of operator. Okay, so the address of that variable is being passed to scanf. Okay, because it is taking as input, right? We don't know what kind of value is given. So we need to pass the address of that particular variable which we defined earlier using a data type. So basically the syntax is scanf, then format specifier, comma, ampersand variable 1, ampersand variable 2, as long as how many which you want to declare. Okay, we are done with input. Now coming to the output. Outputs are displayed on the screen with the help of printf statements, which is also defined on the stdio.h header file. So the syntax of printf is printf format specifier, comma, variable 1, variable 2. We don't have the ampersand symbol for printf. We have it, the ampersand symbol for scanf, because it is using as an address of. Printf, you're just printing the values on the console screen. So for printf, we are just using the values on the console screen. So for scanf, we are not using, they are taking it as user input. So this is the format of printf. Moving on, we have format specifiers. I just told you how important format specifiers are. So this is really one of the most fundamental things in C. We have to learn what a format specifier is, because we will be using it in the program many times. And in the print statement is of course important, because you need to get an output, right? So for the output, we need a printf statement and scanf statement. Scanf is not mandatory, but printf is mandatory for almost all programs. So a format specifier in C is a placeholder used in printf, scanf and other formatted input and output functions to indicate what type of data is being printed or read. It tells the compiler which type of data is being used. Example, integer, float, character. So we need to, just like data types are separating data from one another, and this thing tells us what type of data is being printed or read. It tells the compiler, it helps the compiler to understand what kind of data we have to print. Okay, it is basically for the compiler to understand, not for the programmer, not for the user, sorry. So how it should be formatted in the output or interpreted in the input. Format specifiers are used because C is statistically typed language. So printf and scanf don't know the type of variables you're using unless you tell them. So you need to tell the C compiler what kind of variables you are entering from the keyboard. Keyboard symbol is used as stdin. So standard input. So since you're giving the values as input from the keyboard, that's why it is called as a standard input. So since you're entering the values, you need to make the compiler aware of what kind of values you are entering. So you have to tell it, so to specify it. So we have to specify the format of the values. So that's why it is called as format specifier. So this is the chart which consists almost all the format specifiers in C language. But out of 21 format specifiers, only few are used and few important ones. So we will be doing them. You can take a look at all of this, like %d, %i is used for decimal numbers, %o is used for octal numbers, u is used for unsigned decimal numbers, Small x is used for hexadecimal of small letters, and capital X is used for hexadecimal of capital letters. Percentage S is used for string, C is used for char, percentage P is used for pointer, LF is used for double, long double. So all of these are important. Only the we use it almost in all the programs, but 21 format specifiers is not required. It's defined. That we use normally integer percentage D, percentage F for floating point, percentage LF for double. Sometimes we can use unsigned integer, we can use percentage U. Percentage O is not required unless it's mentioned in the program, but still it's there. And pointers we use, of course, percentage P. Percentage pointers are used mainly in data structures, so percentage P is used. Percentage S is used for strings. This is also again used a lot. Percentage C is also used a lot. And double is of course used a lot. Moving on. We have a short demonstration of a C program with to perform, to see the application of printf and scanf function. How do we use it in a program? So this is the main function. So this is just a program. It's not a complete program. It's just a part of a program, which is the main function. Now int is the return type of the function, and main function is, under the main function we have int age, float height. So height is normally a decimal number, so we are taking it as a float. Int and float are data types. Again, age and height are variables. Now we are taking as input from the user using printf statement. So within quotations we write enter your age, and then within quotations we close the quotations along with a semicolon. Semicolon is a termination statement, and including, which signifies the end of the statement. Scanf is percentage D, comma, address of age. So percentage D is a format specified what type of data you are entering. You are telling the compiler, and where you are entering, it is you are entering it to the address of this variable age you have declared as int. So you are taking the value, what type you are taking from the keyboard, what type of value you are taking, and then you are passing it to the variable age. Okay. Next, printf, enter your height in meters, percentage F, comma, address of height. So percentage F is you're taking the input, what type you're telling the compiler, and then where are you passing it? To the height. Okay, you're storing it in height, address of height. Okay. Finally, last print statement is you are percentage D years old, comma, percentage .2 F meters tall, backslash N, age, comma, height, and then return. So percentage D is again used for, here it is used for integers, and percentage F is used for height, but 0.2 means 2 decimal digits. It will be printed after the decimal point. So the user can input like 10 digits after the decimal point, this. But it will print just 2 values. You're just making a limit to printing. So here, enter your age. This will be printed as on the screen. 20, the user is going to input it. You can input any type of value. You can give 10, 5, 15, anything. And then comes your height, which you are entering. Again, any kind of decimal value. And then in the end, the final output is you are 20 years old and 1.75 meters tall. 20, this 20 is for percentage D. You are percentage D years old means 20 years old, the value which you have entered here for the age. Okay, and 1.75 is the 0.2f value of height which you have entered in the second line. That is printed finally. Moving on, we have preprocessor and macros. Preprocessor is basically something which is not executed in a program, but it is an instruction which is given to the compiler to understand the program. There are certain instructions that you should do this, you should not do this, blah blah. We give instructions to kids, right? We give instructions to students, right? So you have to give certain instructions to the compiler and prepare it to perform a certain function, or like before running the actual code. It is not executed, but you have to give certain instructions to the compiler to understand. You have to prepare it. Okay, just like you go and to an examination preparing yourself, you need to prepare the compiler, and that preparing the compiler is called the preprocessor. So in C, preprocessor is a tool that runs before the actual compilation of a C program. It processes the directrix with that begins with a hash, such as hash include, hash define, hash if def. These directrix helps in file inclusion, macro substitution, and conditional compilation. The preprocessor does not compile code, it just prepares it for the compiler. It does not compile the code, just like I said, it just prepares the compiler. It makes the compiler ready to perform execution of a code. Okay, so hash include is including of a header file. Header file is standard std standard input and output stdio.h, that is a header file. Hash include is a preprocessor. Okay, I hope you understand this better by now. Macros. A macro is a segment of a code defined under hash defined directrix. It allows you to give a name to a constant value or a block of code, making programs easier to read and maintain. So hash define is basically used as a constant keyword. Okay, constant data type, a constant keyword. Like you fix a value of a particular variable as something and you use it continuously in the program. Like you use it in the way as hash define max equals to 20. If max 20, so max value is being fixed to 20. So the number of times you use the variable max in the entire program, it will be used as 20. It will be treated as 20. Sometimes it is something like the constant keyword, or it is something like the you know it is something like the global variable. Moving on, we have decision making, which is again an important aspect a of C programming language. Decision making in C refers to the ability of a program to make choices and execute certain blocks of code based on conditions. It uses conditional statements like if else if, switch, and ternary operator to control the flow of execution. Okay? Decision making is really very important in C because a code has to execute or not, giving choices, just like you go to a restaurant and you have choices. The waiter gives you choices. Do you want this or do you want this? Today's specials are this. If you don't like this, you can have this along with this, or maybe you can have something else. So these are choices. So for those choices are given to the customer. So customer takes a decision according to his own choice. So the decision making in life is important. In the same way, decision making in C language is also very important. Moving forward, so we come to we just learned that there are three types of decision making. If using if statement again it has three types, but one is if statement, one is if else, and if else ladder. Okay, and then it is another one, that second one is switch statement, which is used instead of if else ladder, and then finally the ternary operator controls the flow of execution. So first we will learn how to use the if else statement. So now coming to the if statement. So there are if statements is of three types. One is the if statement, the second is the else if statement or if else, and third one is the if else ladder statement. The syntax of if statement is if within the parenthesis we write the condition, what type of condition we are fulfilling, greater than, less than. It can be used with relational operators, combined with logical operators, or just relational operators will just do fine. And followed by the block, which includes the curly brackets and whatever number of statements we can include, and the statements execute if the condition is true. Okay, next we have the if else statement. Syntax of if else is if, then within brackets we have the condition, and then within the block we have the code to execute if the condition is true. Okay, if the condition is not true, we go to the else part. It is like either this or this. So the else part executes if condition goes false. So again in the else block within the curly braces we have the code to execute if the condition is false. Next we have the if else ladder. Syntax of if else ladder is this or this or this or this or this, it keeps on going. Okay, so if, then we have condition 1 within parenthesis. Again, this, the parenthesis is important. Then within the curly brackets we have the statements or the if block. Second, if the if condition goes false, then it enters into the else if condition. The condition 2 is checked for the else if block. And then within the curly brackets we have the else if block with the number of statements which fulfill the else if condition. If it still goes false, then it finally enters into the else block. Else block is the, again we have the else block with the number of conditions. This is the final block. So first it goes to if, else if, else if, else if. It can be, else if can be a number of times, but finally it should end with the else block. So these are the flow charts to represent the various types of if. You can have a look. It is very easy to understand. Next we come to the second type of decision making, which is the switch statement. Switch statement is an alternative for this if else ladder statement. Now let's go and understand switch statement. This is switch statement. Switch statement is a cleaner alternative to multiple if else for comparing one variable with many values. Okay, first we have the switch and the expression comes, which is the expression where we write here in if else in condition 1. This condition we write it in the after the switch within parenthesis. Then the block is opened. So case value 1 we have, then we have case value 2, then we can have number of case values, and in the end we have the default statement. Case value 1 acts as else if condition. If case value 1 is like the if condition, okay, and case value 2 is like else if, else if, else if, the number of cases we have. We can have n number of cases. Finally the default block acts as the else block of the if else ladder, okay, but at a particular time only one block is executed. All of the blocks cannot be executed. This, the case value 1, if case value 1 case is executed, it cannot execute case value 2 at the same time. Only one of these conditions can be true, and after it is completed we have the break statement. Break statement exits from the switch block entirely and goes to the next conditions. So either one of these are executed. So over here in the flowchart we can see start switch expression, which is again used a process as a rectangle, then case value true. If it is true, then statement, otherwise break. Break, it goes exit. If the break is true, it exits the switch block. It goes out of this switch block. Okay, any one is true. Then it is case 2. Again, if it is true, then it exits. If it is false, case 3 is exited, entered. If this is true, then break statement. Otherwise, if it is false, then it goes to the default block. Default block is the else condition. Default block is not mandatory. It is optional, but it is always best to write it because this is the proper syntax of switch case. Okay. Then now there are certain rules which we have for switch case statement. So the rules are, first, number 1, the switch expression must be of integer type. Number 2, the case labels must be constant or constant expressions. The switch statement which we are using, like the relational operator, any kind of expression, it has to be an integer type. Okay. The second statement, case labels must be constant or constant expressions. This has to be taken care of. You cannot include special characters. So it can either be letters, or it can be, if you include letters, you have to include it within single quotes, otherwise you have to use numbers. Third is the case labels must be unique. The two case labels can't be named as 1 and 1, otherwise the compiler will get confused. Next we have the fourth condition, no two variables have the same value, of course, otherwise the compiler will get confused as well. Case number 5, case labels end with a colon. It has to end with a colon. This is sort of mandatory. Sixth one, the break statement transfers the control out of the switch block. Okay, and both of them cannot be true as well. So only one is executed, and after the execution is done, it goes out of the switch block using the break statement. Finally, the seventh one, the default label is optional. I just mentioned that to you. Moving on, we have ternary operators. Ternary operators is again another type of decision making. It is not a particular statement like if, else or switch. It is an operator. Okay, and it is used as a shorthand operator. I mean, it is used to decrease a long switch, a long, decision making statement in one line. So normally programmers become very lazy to type a lot, so this is like a shortcut. So the question mark is used for true and the colon is used for false. In C, the ternary operator in C is used to as a shorthand operator in, and the way of writing it is an if else statement in a single line. I just mentioned that to you, and it evaluates a condition and returns one of the two values depending upon whether the condition is true or false. The syntax is condition question mark if the value is true and colon if the value is false. Then we have the semicolon. Moving on, and this is the end of the decision making. So now we have a program to demonstrate all the types of decision making statements. So first we have the compiler directrix. Next we have int main, like just we did the preprocessors. Int is a return type of the main function. We can declare it as void as well, anything. Next we have int num. We have a variable we are taking as a variable. Next we are printing, enter the value of the variable. Now we are using scanf to get the value of the variable, %d at the address of num. We are passing the, taking what type of variable it's reading, and then we are passing it to num. Then finally here we have the execution of if statement. If statement, if num is greater than 0, print the number is positive. This is the only if statement. Okay, now we have the type of if else condition. If num mod 2 equal to 0, mod is again the assignment operator, and arithmetic operator, and equal to is the relational operator. We used that concept here as well. Printf, the number is even, else if this is false then it will enter into the else block, otherwise it will just execute the if condition. Next we have the else if ladder. If num equals to 2, then the number is 0. Else if num is greater than 0 and num is less than equal to 10, printf the number is between 1 to 10. So 0 is greater than 0, this is the relational operator. Less than equal to 0 again is the relational operator. Both the relational operators is combined with the help of a logical operator ampersand. So the use of operators are demonstrated as well. Next, finally else if. Next we have the else condition. Finally, if that is also false, it will enter into the else block, where printf the number is greater than 10 or negative. Okay, next we have the switch block. This is the switch condition of the same program, and finally this is the ternary expression. So switch, then the num. Okay, we are taking the value of num. Case 1, if the number is 1, okay, we print you have entered 1, break. If this is false, if the user enters 2, it will print you have entered 2. Otherwise then it will break out of the switch block. If both the conditions are false, if the user have entered 5 or 7, anything, it will go to a default block and print you have entered something else. Okay, then this is the working of switch statement. Now we have the ternary operator. Int is positive equals to. Moving on, we have looping statements. Looping statements in C is used to execute a block of code repeatedly as long as a given condition is true. Loops help reduce repetition and make code efficient when you need to do the same task multiple times. So when we need to run a particular code multiple times, we use looping statements. So it is a particular statement which keeps going on and on until an execution is stopped. So there are basically three main types of loops, that is for loop, while loop, and do while loop. For loop is an entry control loop. While loop is also an entry control loop. Do while loop is an exit control loop. Why? Because it checks the condition when you exit the block of the do while loop. Okay. For loop repeats the block with a counter. While loop repeats a block while a condition is true. It is an entry control loop, of course. Now we will understand each with the help of examples. So for loop, the syntax of for loop being an entry control loop is for loop, then we have the initialization condition followed by a semicolon, then we have the test condition, and then we have the semicolon and followed by an updation condition. In one line we have the initialization condition, test condition, and update condition. Initialization conditions, the code starts from the initialization condition I equals to 0 or any kind of value which we initialize at first, and test condition is the condition which keeps on checking a number of times at each iteration. Updation condition is I plus plus or I plus 2, I plus equals to 2, anything it can be. So initializing condition is only executed once. Update test condition is checked every time it runs, it goes in every iteration. So this an example for int I equals to 0, this is the initialization condition, I less than 5 is the updation condition, I plus plus. Within brackets we have printf %d \n. \n is an escape sequence for new line. Escape sequences are also important in C because we don't have a particular statement for new line printing, comma I, and this will print from 0 to less than 5, 0, 1, 2, 3, 4. Here, this is the output. Next we have the while loop, which is also an entry control loop, and the syntax of while loop is initialization condition comes first, then while, within brackets we have the test condition, and within then we have the block of the while loop code to be executed, and finally we have in the end which is the updation condition, which goes to the next iteration. Example, here int I equals to 0, I less than 5, then in print %d n I plus plus. So this is the entry control loop of while. So this is basically the same thing as for loop. The position of each of the conditions, the placement is different. So again it runs from 1, 0 to less than 5, 0, 1, 2, 3, 4 is printed as well. Next we have the do while loop, which is an exit control loop. The syntax of do while loop is again initialization condition is first, then we have do and the code is there. Then we have next we have the updation condition, and while it is exiting we have the while condition. So the test condition is checked when the loop is exiting. So that's why it is called an exit control loop. And exit control loops runs one more time compared to the entry control loop. It is used, it is not very widely used, but it varies. So the output for this is again 0, 1, 2, 3, 4. Finally, we have the break statement versus continue statement. The break statement terminates a loop immediately when it is encountered, whereas the continue statement skips to the next iteration and jumps to the next iteration. So it's for the break statement, it comes out of the loop immediately. Immediate statement after closing brace of the loop will be executed. The syntax of break statement is according to this flowchart. It is very easy to understand. You can have a look at this. The continue statement will cause the evaluation of the condition in while and for loops. Like the break statement, the continue statement should be avoided because it makes the code hard to read and debug. Of course, both of them, unless and until it's required, you should not use it. In for loop, sometimes break statement is used. Continue is also used. It depends on what type of program you're coding, so, and how it is using. So both are useful, but you need to be careful while using so because of the flowchart. You just should look at the flowchart and understand it properly. Okay. With this, we come to the end of the first chapter. And now we have one program to demonstrate all the concepts which we learned in the first chapter, including from keywords, data types, preprocessor, main function, decision making, and looping. So the first line hash include stdio.h. Stdio.h is the header file which I spoke about. Include is the preprocessor. We don't have a macro here. Then int main. Int is the return type of the main function. And yes, I would also like to add that all the functions can call each other, but in the end main functions calls all the functions, and the operating system finally calls the main function to execute the program. Now inside the main we have three variables, I, num, and sum. Sum is initialized to 0. Print, we have enter a positive number, then we are taking a number input from the user, then we are checking if it is less than or equal to 0. If the condition is true, it will print invalid input, enter a positive number, else it will go inside the loop. It will cover the concept of loops. I equals to 0, I less than num, I plus plus. I equals to this is the for loop condition, followed by the initialization, test, and updation expression. Then inside the loop we have sum plus equals to I. Sum plus equals to I is a shorthand operator which means sum equals to sum plus I. Okay, since the programmers become very lazy to type, we just use shorthand operators. It has the same usage. Now after the for loop is executed, we have the printf statement is a sum of numbers from 1 to %d num comma sum. Okay, then we return 0 and end the, which signifies the end of the function, and finally we have the output. If we entered 5, we will get a positive number. Sum of numbers from 1 to 5 is 15, and if we enter -2, it will read as invalid input. Please enter the positive number. Now we will be going to the next chapter of our syllabus, that is arrays and strings. Arrays and strings, this is again a very important chapter. It will cover all the topics about arrays and strings using C, and it will include the following subtopics. Among arrays we have the introduction, then we have the one-dimensional array and two-dimensional array. We have the difference between the two and declaration, its initialization, and then we will have example programs, and to understand the concepts of arrays, to understand it better. Then finally we have we will go to the second part of the chapter, which is strings. We will know what strings are. Then we will learn how to declare a string, declaration and initialization, and read and write operations of strings, which is again very important. And finally that will be the end of the second chapter. So let's begin with the second chapter. An array in C language. An array in C language is a collection of elements of the same data type stored in contiguous memory locations and accessed using a single name with an index. It allows you to store multiple values like a list of numbers or characters under one variable name instead of declaring separate variables. So a group of same data types are stored in an array. That is basically an array. We will understand how to declare an array in the coming slides. So this is the array declaration. First array declaration, syntax of array declaration is first we need to have a data type followed by the array name, and within square brackets we have the size. Okay. Next we will have the array data type of an array. Again array name, size 1, size 2. This is a double dimensional array or any kind of array dimension depending upon the size. So now this is the representation of pictographic representation of how elements are present in an array. Like this is the elements, these are the square blocks 2, 4, 8, 12, 16 and 18. These are the elements present in the array, and 0, 1, 2, 3, 4, 5 are the array indices. So we access an element with the help of an array index. Okay, now in array declaration AR equals to 5. So over here an array of size 5 is declared, and the memory location is saved for 0, 1, 2, 3, 4 in this way, contiguously, one after another in blocks. An example, here it is an declaring of array of integers, int arr int. Arr int is the name of the data is a variable name, int is a data type, and within brackets is the 5, which is the size of an array. Declaring an array character of arrays, character array of 5 size. This is basically a string declaration. Anyway, moving on, we have array initialization. Array initialization can be done in three ways. The three major ways. First one is array initialization with declaration, that is with the help of size, right? Then there we write the data type name followed by the array name. Next we mention the size of the array, and then we have we enter the values with the help of curly braces. Okay, so here we declare an array of 5, 2, 4, 6, 2, 4, 8, 12, 16. So here 2, 4, 8, 12, 16 contiguous memory locations it is stored in, and the indexes are 0, 1, 2, 3, 4. So this is one type of array initialization with declaration using size. We can also do it without declaring the size, as the compiler will take it automatically in these cases where the syntax is data type, then we have the array name, within square brackets we don't mention the size, and then we will keep entering the values as many as we want. This is an example, data type. The compiler can automatically determine the array size in these cases. I just mentioned that to you. Now coming to the third type of array initialization, we use it using for loops or any kind of loops. We use it by using loops. Initialize the array after declaration by assigning the initial value to each element individually. So in this, this is the code to demonstrate the following. For int I equals to 0, I less than n, I plus plus. Array name I. So within square bracket, that is the index. At 0th index, what element I am entering, and that is also equal to I. So as 0th element. Next is second element. First element, at first index, what kind of element I am entering. So that way you are inputting or appending the initial or initializing the elements in the array. So we can use it, we can do it with the help of for loops, while loops or do while loops to assign the value of each element. All the loops are the same. I mean, all the loops are not the same, but every loop has the initialization test and updation condition. We can use any loop to use for array declaration and initialization. Okay, moving on. We have an example code to understand. So here inside the main function is declared as void, so it won't return a value in the end. Now in the main function, we are declaring it, we are initializing it with the help of size. So int ar5, it has 5 elements. Next we are initializing it without size. Again it is 5. The compiler will automatically take the size as 5. Next we are taking it we are taking array of with size 5, and we are running the loop from 0 to 5. So the loop will run from 0, 1, 2, 3, 4 till 4, and then I plus plus. ARR of I, which is ARR of 0, which is equal to float I into 2.2. Why are we writing float here? Because the data type of I has been declared here as int. So for integer variables, we cannot use decimal points to calculate, to initialize variables, to initialize the values inside the loop. So we need to typecast the value of I to float in this case, because I is an integer multiplication with float 2.2 is a floating point data type, floating point variable. That is not possible. So we need to forcefully typecast or manually typecast the value of I from int to float in this particular program. This is basically called typecasting. Next we have the for loop I equals to 0. This loop is for printing I less than 5, I plus plus, print, and we have all the loops for printing. Next, moving on. We have accessing elements of the array. Indexing is the array in the array always starts with 0. So in the array index starts with 0, and the last element is n minus 1. Since if the size of the array is declared as 5, it will take 0 to 4, because 0 is being considered as well, where n is the number of elements. So we just take the index with the where the size is being stored. So ARR of 0 equals to 1. So at 0th position 1 is going to be appended. So that way, that's how we are going to access ARR of 0. So 1 is going to be printed if we print it. Next, moving on, we have a program for element access using array. Hash include stdio.h void main. The v should have been in small letters. This is my bad. Next, inside the main function, we have declared an array of size 5, and then we have initialized the variables in the array. Then we are printing the array element at ARR of 2. So 0, 1, 2. This will print 35. Next statement, we are having element at 4. 0, 1, 2, 3, 4. Next element, it is going to print 55. And the last print statement, ARR at 0, which is 15. Then it is going to print 15. So first it will print 35, 0, 1, 2. Then it will print 4, 55 at the element at 4th index, which is 55. And finally at the element at 0th index, which is 15. So it is going to print 35, 55 and 15. Next. Now we have update array element. update the element of an array with a given index I. So the syntax is array name I equals to new value. We can change the value of a particular element this way. So in this program, let's see the look at the program. In the main function, we have an array of size 5 where we have initialized the variables 10. We initialized constants as 10, 20, 30, 40, 50, and at 0th position we are changing the value to second position index we are changing it to 100. So 0, 1, 2. So 30 is being changed to 100. So if we print the element at second position now, it is going to print 100 instead of 30. So we are modifying the element at the index 2. Now traversing array using loop. Traversing means traveling to each element of an array. We are going to each individual element of an array in a line. We are visiting each element of an array. So printf elements in an array from 0 to less than 5, and then we are printing all the elements in an array. So this is going to print 10, 20, 100, 40, 50. 30 is being modified here. Next, moving on, we have array traversal. I just explained array traversal means visiting every element of the data structure. Arrays are also called data structure because a collection of data is being collection of same type of data is being stored in a particular data type. So it is also called a mini data structure, you can say. See, array traversal uses loops to iterate through each element in an array. So array traversal means visiting elements. So first at 0th index, which will access 2, then at second index, first index it is going to access 4, then at second index it is going to access 8, third index it is going to access 12, finally at fourth index it is going to access 16. So this is with the help of loop we are visiting each element of an array. And here we have an example. So for int I equals to 0, I less than n, I plus plus. Within the loop we have array name I. So this is in the same way we used array initialization using loop. We are initializing the values with the help of loop, but we are not initializing here. We are just visiting every element with the help of loop. It is the same way. Moving on, we have one-dimensional array and two-dimensional array. Let us understand the difference between one-dimensional array and two-dimensional array with the help of example. So now we have one-dimensional array and two-dimensional array. So one-dimensional array, coming to the syntax of the one-dimensional array, we have the array name and followed by the size within the square brackets and semicolon. Semicolon means the termination of the statement. So one-dimensional array has memory locations are saved in this manner. So 1, 2, 3, 4, 5, 6, 7, 8. This is the contiguous memory locations, one after another. The values are stored inside the array. Okay, this is basically a one-dimensional array. Coming to the two-dimensional array, the syntax is data type followed by the array name. Then within the square brackets we have the size, but we have to mention row size and we have to mention column size. Okay, so if we mention 2, 2, it is a 2 by 2 array. It is something similar to a matrix which we do in mathematics. So here we have a two-dimensional array. This is a picture of a representation. So this is a 4 by 4 two-dimensional array. So these are how the elements are placed in the two-dimensional array. 4 by 4 two-dimensional array. Now let us understand it with the help of an example. So one-dimensional array, here we have the main function. Inside the main function we have taken a character array as of size 6. We have entered SIT hyphen SHYD followed by the null terminator. The /0 means null terminator, which signifies the end of the array or end of a string. Okay, and a string is also basically a collection of character arrays. Anyway, coming to the next part, we have the initialization condition I equals to 0 while ARR of I not equal to 0. Here ARR array of I. So first time when the condition is executed, ARR of I at 0th index. So ARR of I, ARR of 0 is not equal to 0. So we are checking the element which is present in the 0th index if it is equal to 0 or not. So in the element present in the 0th index is S. Is it a null terminator? No, it is not. It is not. So this condition is true. Now we will enter inside the while loop block and we will printf percentage C ARR of I. So percentage C ARR of I is what? 0. Here S will be printed. I plus plus. Okay, updation condition is true. Again I plus plus, I becomes by what? 1. Now ARR of 1 is not equal to 0. We are checking. Is it? No, it is not. It has I value. It is not a null terminator. Then we will go inside the loop again and then print I after that. Okay, then again I plus plus. So this condition will continue as long as it reaches the null terminator, which is here. HYD till here the null terminator is reached. It will exit the loop block and then come to the return value, which signifies the end of the main function, and then the code will come to an end. Execution will come to an end. Now coming to the two-dimensional array example. So coming to the two-dimensional array example, we have the main function and then we have initialized an array of row size 2 and column size 3, and then we have initialized the elements as well. Then we have printed the array. Now we need to run two loops. Okay, one is for the row size and one is for the column size. So first outer loop is of row size, so which is starting from the 0th index to 2 less than 2. So it is going to print 0 and 1. So the first loop is going to run twice. Okay, simultaneously inside that loop we are taking another loop, nested loop. So nested loop is basically a pregnant loop, a loop inside another loop. So anyway, the second loop is for the column size. Column size is what? 3. Second loop is for column. So the loop is going to run from 0 to less than 3. 0, 1, 2. It is going to run 3 times. So when the I loop executes once, that is at 0th condition, the J loop will be executing 3 times. So for one condition of I, J loop is executing 3 times, and for the next condition of next iteration of I, J loop is executing again 3 times. So the J loop is for the column. Now we are printing the percentage D array of I comma J. So I is what? 0 here and J is 0 here. So 0 comma 0th index, whatever is present at 0 comma 0th index, that is the first element that is being printed. Okay, and then J equals to 2. So J equals to 2, then J equals to 1. 1 is less than 3. So now the J loop is again running. So it is printing ARR of I is again 0, 0 comma 1. So the 0 at 0 comma 1th element, whichever element is present, that is going to be printed. I think it is going to be 20. Next again J is going to be 2. Then it is going to print 0 comma 2. At the first row, third column, 30 is going to be printed. Now it will exit. It is going to be I equals to 3. 3 is less than 3 is not equal to 3, or 3 is not equal to less than 3. Now it is going to go to the print outside the loop, and it is going to print come to the next line. And when it comes to the next line, I loop is updated. I becomes 1. Again for a value of I1, 3 times J loop is executing. Just the same way it will keep on going. So the outer loop is being executed twice, and with each execution of the outer loop, the J loop is executing inside it 3 times. So this is called nested loop. The concept of nested loop is being used in a double dimensional array, and the number of dimensions, it is the number of loops you need to take. So if it is a three-dimensional array, you need to take 3 loops. So that is again going to be difficult to understand, but it is fun. So moving on. We have the properties of an array. So there are 6 properties mentioned here. So which include number 1, fixed size, number 2, homogeneous collection, number 3, indexing in an array, number 4, dimensions of an array, number 5, contiguous storage, number 6, random access. Coming to the first point, fixed size. An array in C is a fixed size collection of elements. Point number 2, The size of an array must be known at the compile time and it cannot be changed once it is declared. It is not like, unlike dynamic memory allocation, the size of an array cannot be changed once it is already declared. You need to, you can keep a very large size and use very less amount of the data. That is still fine, but you cannot increase it later on. So you must be careful about declaration of the size. Homogeneous collection only store one type of element in an array. So we cannot store characters, integers, strings all together in one array. So it only stores elements of one particular type. No restriction on the number of elements, as much of as elements we can enter. If the size, if we don't mention the size, if we use initialization without mentioning the size, the compiler will take it automatically. But the type of all these elements must be same. We need to make sure of that. Indexing in an array. The array index always starts with 0 in C language. It is mandatory. Means that the index of the first element of the array will be 0 and the index of the last element will be n-1. We already understood this concept. Coming to the fourth point, dimensions of an array. A dimension of an array is the number of indices required to refer to an element in the array. It is the number of directions in which you can grow the array size. You can grow the array size in any number of dimensions. So, this is also important. Contiguous storage. The elements of an array are stored continuously one after another in the memory. Just like this. We have seen here, one after another the elements are being stored. So this is called contiguous memory location. So contiguous memory, it is one of the defining properties of an array in C, which is also the reason why random access is possible in an array. So by using random access at any element, using the index of that element, we can access the particular element stored at that particular index. Random access in C allows random access, just that is what I explained right now. Meaning any element can be accessed you instantly using its index with a constant time using complexity. Now we are coming to the advantages and disadvantages of an array. Advantages of an array in C. Advantages are random access and fast access of elements using the index. That's just what we understood right now. Next, we use fewer lines of code as it creates a single array of multiple elements. Of course, we don't need to access enter element 100 times. A collection of elements is being stored as in one unit. Traversal through the array becomes easy using a single loop, of course, because while using a single loop we are calculating, since the array elements are only stored as contiguous memory location, traversal is also easy because it accesses every element at a time using one particular loop. Sorting is also easy because it can be accomplished. Sorting is easy because of the contiguous memory location, and it can be used with fewer lines of code. Disadvantages are quite important because advantages we will be able to write on our own. Disadvantages we need to memorize it. So coming to the disadvantages, allows a fixed number of elements to be entered, which is decided at the time of declaration. Unlike the linked list, an array is not dynamic. That's what I explained it to you. In a heap memory, a lot of storage is there at random. When you access a memory in heap during dynamic memory allocation, you access it using a different header file and everything is separate, but there are functions also for it. But that is not the memory of contiguous memories locations like in an array. One after another in long linearly, we are not, the memory is not like that. So array declaration has to be done first, and so that particular number of units or bytes is stored for the particular execution of the program. But in a linked list, you can increase the size or decrease the size as much as as much as it is required in the program. So linked list and dynamic memory allocation, we don't have linked list in syllabus, but dynamic memory allocation is there in the last unit pointers. We will be covering it up at that time. I will explain it better, but this is just the gist of it. Array is contiguous memory location. Linked list or dynamic memory allocation is a heap memory, which is a random memory which can be expandable or decreasable. But array cannot be. Insertion and deletion of elements can be costly since the elements are needed to be rearranged after insertion and deletion. The elements have to be rearranged, so it becomes very tiresome and consuming, and we have to apply a lot of logic, and the code becomes complex. So these two disadvantages we have to remember. Moving on, we have an example codes. So this marks the end of the first part of the second chapter, which is arrays. So we have the example codes. First example is we print the average of a given list of numbers. Second program is to find the largest number in the array. So coming to the first program, we have the main function, which is return type is int, and we have declared two variables, n and I. Float sum we have initialized as 0, average we have taken another variable as float. Now we have the printing the elements, and we are taking the elements as number from the user. We have float numbers at n, the number of elements we are using. That is basically here we are declaring the size. We are taking the size from the user and putting it in this numbers. So from user we are accessing the size of the array. Print elements of the number. Now we are coming to the for loop. 0, I equals to 0, I less than n, I plus plus. Scanf percentage f, address of num at I. So this is how you use to a loop to append the values in the array, to append the elements in an array using the array index. So this part is pretty important. You have to take a look at this and understand it very well. Scanf percentage f is what was format specifier. Address of numbers means numbers is an array of float type. So address of numbers at what position? I. First time it is going to be 0. At 0th position you're taking the address and taking it as scanf. You're taking it from the user. You're taking it and then appending the values inside the array. After you are appending the values, you are taking the sum. So sum plus equals to sum numbers at ith position. Okay, I hope it is clear. Just remember the scanf statement properly because we tend to forget this. Anyway, after you have calculated the sum, we come out of the loop and then calculate the average, sum divided by n, and then we print it with 0.2f with 2 digits after the decimal. Then we return the value as 0, and then which marks the end of the main function and end of the program. Next program is to find the largest number in an array. Here in the main program we have taken these variables and we have taken an array of numbers which is of size 6. We have printing this. Finally inside a loop we are taking it from 0 to n. This is similar to this statement as well. I think I just made it clear to you. I won't explain it again. Coming out of the loop, we are taking the largest number. Here the first number we are taking of the array, first element of the array, we are initializing it to largest. Since largest over here, it does not have any value, pre-existing value, we are accessing the first element of an array, numbers at 0th position. So say at 0th position the user has entered 65. So largest, we are taking the value of largest as 65. The number at 0th position is 65. Now we will use another loop which will start from the first position. Okay, so at 0th position is 0th position is what, 65. It is completed. So now we have to check, go to what, first position. So the loop is starting from 1. I equals to 1, I less than n, I plus plus. If numbers at ith position is greater than largest, then largest equals to numbers at ith position. So the number at ith position means the number at first position. So suppose the number at first position you have entered as 75. So 75, we will check if 75 is greater than largest. What is the value of largest? Largest is 65. So 75 is greater than 65. So this condition is true. Now, so the value of largest, we are changing it from 65 to 75. So largest equals to number at ith position. Ith position means what? 1, which is what? 75. So now the value of largest is being changed from 65 to 75 here. Now the same way the loop is going to keep running till n. I hope I made this clear. After this we will exit the loops block and then come to the print statement. the largest number is percentage d backslash n largest. Backslash n is again for the new line, and in the end we will terminate the main function with the return type. This marks the end of the first part of the second chapter. Now we will come to strings. A string in C language. In C language, a string is a sequence of characters, letters, numbers, or symbols terminated by a null character. Unlike some languages, we have built-in string type. In C, it is represented as a character array. A string is a character array, so using without braces will give the base address of the string. Okay, so we don't have a particular data type or keyword as string, as I just mentioned the same thing to you earlier. So we need to express a string in C as a character array, as a sequence of characters. So A, B, C, D, they are individual character A, B, C. So we add all the characters and make a word, and we add words and make a sentence. The same way, every character we take a array of characters, and then that is considered as string. Moving on, we have string declaration. So the syntax of string declaration is, since we just learned that it is a character array, so it has to be, the data type is mandatorily char. Then we have the string name, and then we have the size. It is the same thing as character array. Extra, terminating null character backslash n is used to indicate the termination of a string that differs strings from normal character array. So we have to use a null terminator which will indicate the difference between a character array and a string. So null terminator backslash n means the string has ended. This is a signification, it is a point which will tell us that a string has ended. Otherwise the compiler won't understand that. Moving forward, we have string initialization. String initialization, it is again done with two ways, with size and without size, and it can be mentioned within double quotes, or it can be mentioned within, like how we access a character array, so within curly braces. So without size, we can use it as within double quotes SITHYD. This will be saved as automatically SITHYD this way. We can all these ways are actually the same. Here we are using a size which is 50, here we are using a size which is 50, we are using it with the curly braces and without the curly braces. All of these are correct. You can use any way which you are comfortable in. Moving on, we have an example. We just learned how in what initialization and declaration of a string, right? So we will be understanding it with the help of an example. So the program goes as, there are two programs actually. First, in the first program, we have a character array str of 50 size. Then we are taking scanf %s str. So we are reading the string and then we are printing it. Str, here it is a declaration. Again, here it is the reading of the string, and here we are printing the string. In str is a character array, so using str without braces will give the brace address of the string. So we need to keep this in mind. The bracket, square brackets, is quite important because it signifies the array. Otherwise, base address, what will we do with the base address of the string, right? So coming to the next program, in the main function we have declared and initialized the string. Here in this way we just learned within double quotes we have inputted SITHYD. This will be saved as within curly brackets. Also you can write it as character, each character separately. Both are fine. Now we are printing this. Then we have taken a variable as length, and length equals to str length. We have calculated the length of the string. So what is the length of the string? 0, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. 6 is the length of the string, but the indexing will start from 0. We need to make sure that. So this is the length. This will display it as 6 over here when we are printing it. So this is strlen is a string function which is again not defined under stdio.h. We have to take a string header, string.h header file, which we need to include it. We will be learning about the string functions in the next slides. Moving on. Reading a string separated by white spaces. It is done in two ways. fgetS function to read a line of string, use or getS to read characters from the standard input stdin. Standard input means stdin means keyboard, and store them as C string until a new line character. Additionally, we can use scanset inside the scanf function to specify characters and input patterns. Moving on, we will understand them with the help of examples. fgetS, getS, scanset. Okay, so in this program we have the main function where we have taken a character array of size 20 with using the scanset. Over here this way we are taking input, and then finally we are printing it and then returning the value. Next we are seeing the demonstration of fgetS. Here we have used a macro which we learnt in the first chapter, preprocessors and macros. So this is the macro. Max, we have defined it as 50. So whenever we use the variable max in the entire program, it will be considered as 50. So void main char str max. So max is of what size? 50. So next fgetS str max comma stdin, printing the string. We are using the fgetS function, and then we are putting the fputS function. So getS gets the values from the keyboard and putS displays the values on the screen. So fgetS is used to read strings from a file into the character array passed as the first argument to the function. This function has three arguments. First is an array where input is stored. Second is the argument where it is used to specify the number of characters to read, including the null terminator. And third is used to specify the file stream for where to read the input. Okay, so the syntax we understood, of course, and it is always safer to use fgetS rather than getS, because getS has a limitation. The limitation of fgetS is that it accepts a character array argument where it stores the characters read. However, it is the duty of the programmer to ensure that the character array is large enough to accommodate all the characters read by getS function. getS function does not check the size of an array passed in an argument to the function. Hence, it may cross the memory boundary of the array. So, memory boundary it is crossing. So, it is going to cause a lot of damage, right? So, if the memory is being tampered, then it becomes very difficult. It crosses the memory boundary of the array if it gets more characters in the input than the array can accommodate. This may result in some unexpected system fault. But fgetS is better to use. Why? Because in order to read inputs from the keyboard, it has an option to specify how many characters to read. So this helps the programmer to check the number of characters to read from the input. However, this function is particularly meant to read inputs from a file, and we use stdin, which means the keyboard, stands for the keyboard and the standard input device. fgetS, unlike getS, reads the new line characters from the input and stores it in an array. Hence, we use it to check for the new line character and replace it if it is not desirable. Okay, so it is best to use fgetS rather than getS. And putS means we are getting the fgetS, we are getting it from the keyboard, and here we are putting it and displaying it in the screen. Okay, coming to passing the strings to a function. Here we have taken two functions. One is the main function and one is the print str function. So in the print str function, we have taken one in the parameter list. We have taken a character array str, and then we are printing it. Printing it. Then in the main function, we are taking another character array std then sid and then we are printing it, and we are passing. This is the function. This is the function return type is void. This is the function name, function argument list, and this is the function for printing the string. In the main function, we are using this. We are calling this function over here. We will understand functions in this concept in functions in better. So print str over here. This is the function name, and we are putting the value of str here, and we are passing it to this function. So this is the calling of the function. Okay, this is function definition, and this is function call. We will understand these concepts properly in the next chapter. String functions are defined under std string.h header file. So there are 7 functions. I'm so sorry to read it. String.length, this returns the length of the string. Copy, strcpy, copies the string to string 1, and string strcmp compares the first string to the second. strcat concatenates the first string with the second string, and results stored in the first string. lwr, it converts it into lowercase. strupr converts it into uppercase. str first occurrence of s2 and s1. Here this is used to check the substring. String.length function. String.length function is used to calculate the length of a given string, and it is defined on the string.h header file. It doesn't count the null terminator. So this is a very simple code to understand the concept. Here we have taken a character array of sithyd. Int length, we are calculating the length. We are getting the length of str using the strln function, and the variable we are passing here, and now we are printing it, and we are returning the value. Moving on. Next we have strcpy function. It copies s1 is a destination string, and s2 is a second string, which will be copied to first string. So here we have the main function. We have 2 strings, hello world and hello sithyd. We are printing both the strings. Now we are copying str1 to str2. str2 will be copied to str1, and now we will print. After we will print, it will print hello world, hello sithyd. This is going to be the final result after printing. Moving on, we have strcmp function. It basically compares 2 strings lexicographically, word by word. It will keep checking. Even if the length of the string is same, it will give us an false. It will return as 0 or false, because it will compare letter by letter lexicographically, word by word. If it is a small letter, even if the same string is present, it is going to give us a false result. So all the characters are given in this is both strings at the same time. S1 has greater ASCII value than the corresponding character in S2. S1 has lesser ASCII value than the corresponding character in S2. So in this program is a short program to demonstrate. We have both the strings, and we compare it, and this will result in a true value. Next we have strcat function and strncat function. So this is again like fgetS and getS. strcat, both are used to concatenate 2 strings, but strncat is safer because the buffer string is not being considered. It checks. We will understand the difference later. Now let's look at the code. This concatenates string str2 to str1. Hello world. This is, and then strcat concatenates str2 to str1. So in the end, when we are printing it, it is going to print hello world. Over here, second program, the same thing is taking place. So moving on. Let's see the difference between strcat and strncat. So it appends a full string. This also appends most of the characters. Buffer safety, yeah. Buffer overflow, it happens. Again, it doesn't check like getS. It doesn't check. It keeps on adding characters, reading characters. So in the same way, buffer overflow can happen. Buffer safety is very important actually. It prevents overflow. Null terminator adds null terminator in the end, and this also terminates null terminator in the end. When destination has enough space, when destination is limited. So it's always safer to use strn instead of strncat. Why do we have to risk taking using strcat? because what if the system crashes if the code is wrong, right? Because C programming is very much related to the operating system, keyboard, hardware, everything. So what's the point of making the system crash, right? Let's use strn safer because it is strn because it is safer. Str function, this is used to check the substring is present or not, used to find the first occurrence of substring s2 with the main string. So s1 is the main string and s2 is the substring. We have to check that if s2 is present in s1 or not. It returns a to point the first character of s2 is found in s1, otherwise a null pointer if s2 is not present. Okay, pointer concept we will come to the last chapter, but just remember is a pointer points to a particular value. Okay, for now, if s2 points to an empty string, s1 is returned. Okay, in this program we are taking it as an example. In the main we have taken two character arrays SIT, and IT. So char we have taken it as a pointer, and this pointer we are accessing it str using this function. We are taking checking that s2 is present in s1 or not, and then finally we are printing it, and then we return the value to 0 and exit the main function. So that was the end of the second unit. Now we are coming to the third unit, which is functions. So now we have reached the third unit, which is functions. So functions is also very important this chapter. We are going to cover a lot of topics which will include introduction, function definition, declaration and function call, arguments and parameters, local variables and global variables, parameters, passing mechanisms, call by value and call by reference, recursive function. So we will be covering all the topics. So let us begin, and we will of course understand the codes with it. So let's begin. So a function in C language. A function is a set of statements to perform specific task when it is called. They are the basic building blocks of C language that provides modularity and code reusability. Statements of a function are enclosed within curly brackets, which have certain meanings and performing certain operations, also called subroutines or procedures in other languages. Okay, a function in C is a named block of a program which is designed for a specific data processing purpose. It may take data inputs through the arguments, do the processing and may returns the value. It may be called to action and when it is needed. Okay, so a function is very important. Now moving on, we have the syntax of a function. A function can be divided into three basic aspects, that is function declaration or function header, which is not mandatory but it is advised to do it anyway, but it is not mandatory. Function definition, that is, or the function body, it is mandatory. And function call, it is of course not mandatory. When you need it, only then you will call a function, right? You will call a particular function by putting all the dialing it like you dial in the phone. You'll call it only if it's necessary, right? So these are the three basic categories. We will learn this deeper. So this is function declaration. Function declaration is the syntax of function declaration is return type, the name of the function, and parameter list. In the parameter list we have the first parameter and the second parameter, followed by a semicolon. Semicolon is mandatory for function declaration because otherwise there won't be a difference between function declaration and definition. And we have an example here, int sum. Int is the return type of the function, sum is the function name, int and within the brackets, within the parameter list we have two arguments, which is int a is the first argument and b is the second argument. Okay, so a function header defines the name of the function by which it will be called, the parameters that will receive the inputs, and when it is called, and the return type, which tells us what type of value will be returned in the calling the function. The rules to name a function is the same as the rules to naming a variable. It should not start with a number, it should not contain any space or special characters, and it should not be as same as the C keyword. The parameter list follows the function name as it is enclosed by a pair of brackets. The parameter list in the list are declined by a comma, and the parameter receives a copy of the values or called arguments passed to them at the time of calling the functions. They act as local variable to the function. Okay. Coming to function declaration or function body. First, again, we have the return type, then function name, parameter list, parameter 1, parameter 2. We'll keep on continuing, but we don't have the semicolon. So this marks, then we have the function block. Basically, the body of the function, what tasks we have to perform, it has all the tasks. So this is the most important part of the program. It is mandatory. Function declaration is not mandatory, but this part, definition, is mandatory. Okay, and this is the flowchart to represent. Int heading is the function name, int is a return value, void is the parameter list, no semicolon should be present, then inside it we have the statements and then we return the value. So the body encloses the code which defines the data processing, the steps of the function and declaration of the local variables that are used within the function. The body may contain return statement that helps the return a result of the processing and the marks to exit the point of the function. In the function, if a function does not return any value, then we may omit a return statement, in which case it is marked as void. Okay. So at function call, when we need, only that time we need to call the function. So a function call is a statement that instructs a compiler to execute the function. We use the function call and the parameters in the function call. Okay. So this is how the function call takes place. In the main function over here, int add sum 10 comma 30. Sum is what is function which is declared here already. Some int which has two parameters a and b. So we don't need to write the data type of the parameters because it's already mentioned over here. We just need to pass two values, that is 10 and 30. 10 is being considered as a and 30 is being considered as b. So inside the function we are returning a plus b, which is 10 plus 30. Over here int add value is being returned as 30. So over here from the main function it is going to the add function, it is performing the task and then coming back to the main function and then printing it. Okay. This is how function call works. Moving on, we have an example. So this is the normal example how we write a code for addition of two numbers, and this is the same code with the help of functions. So in the main function we have declared two numbers and a sum. Then we have entered taken two numbers as input from the user. Then we have calculated that sum and we have printed it. Okay. Over here we are taking a function which is of add name, and the return type is int, and int we can actually include the parameters or we can't. But it's advised to include the arguments passed in the parameter list. So in the main function we have again two variables. We are taking it as input, and result is we are taking a new variable result which is equal to add. This is the add function. We are calling it here and then we are passing the value of num1 and num2. So the num1 will be included here and num2 will be included as a second argument. So then it will perform the addition of two numbers and then print the result after coming back to the main function. Over here, this is the function declaration. This is the function definition. When we use a function declaration, it is mandatory to write when the function is declared before the main function. Definition can be after the main function. But if you are writing the definition first, then you can write the main function in the end. It is always advised to write the main function in the end. Declaration is not mandatory. I personally don't use function declaration much. Moving on, we have function return type. I just explained what is a function return type is. Before the function name, you mentioned what type of value it is going to return in the end, which is the ending point of the function. So function return type tells what value will be returned at the function is executed. We don't want to return a value, then we use void data type. So this is how it is done. Moving on, we have function arguments. It is also known as function parameters, data that is passed to a function. So these are the two arguments inside the parameter list, or they can be called parameters as well. This is the same thing. We just did this part. Moving on, we have the conditions of return types and arguments. Functions can be called either with or without arguments and might return values. They may not return values after calling. So the first type is function with no arguments and no return type. So this function does not take any arguments as input and doesn't return any value during calling. Okay, function call, at function call. Function with no arguments and with a return value. No arguments but with a return value. So these type of functions don't receive any inputs from the calling function but return some value to the calling function. Okay, I hope it is clear. Next is function with argument and with no return value. Argument and no return value. So this type of function accepts input from the calling function but does not return anything to the calling function. Okay. Last we have arguments and with return value, which is most extensively used. These are the most common type of functions that accept some inputs from the calling function and return some value to the calling functions, obtained as a result of processing the inputs by the function. Okay, I hope this concept is clear. Moving on. How does a C function work? Let us learn that. First, this is a sequence of steps. You can call this as writing an algorithm, but it is not, because you need to write down 1, 2, 3, 4 points. Anyway, first we have to declare a function. Declare a function is a step where we declare a function and specify the return values and parameters of the function. Okay, we just did this and understood this. Next is defining the function. This is where the function body is provided. What type of statements has to be executed, what type of operations need to be performed when it is called. So it specifies what a function does, including the operations to be performed when the function is called. Calling the function. Calling the function is a step where we call the function by passing the arguments in the function. We pass the arguments to the function. Like we use the dial code to call a number and then call them and ask them to do this type of thing. Why we have called them, we tell them, right? So why we have called them is the argument passing to perform a specific function, and calling is basically calling that person. Executing the function. After call, execution takes place. When you call the function, then only it executes, right? Otherwise, when you don't call the function, it's just defined and it is just there. You don't have and it has no purpose. What is the point of writing it? You need to execute it, right? After calling it, it goes inside the function block and executes all the statements. Execution is a step where we can run all the statements inside the function to get at the final result. Then after execution, we will come to the end of the function, and then if it has a return value, it will return a value. Otherwise, it won't return a value if it is declared as void. Returning a value is a step where the calculated value after the execution of the function is returned. Exiting the function is the final step where all the allocated memory of the variables, functions, etc. is destroyed before giving full control back to the caller. Okay? So it will return a value, and all the variables which are created during the parameter list, at the parameter list, or the arguments which are created, with all of them gets destroyed. And then it comes back to the caller, whichever function has called, main function or anything whichever has called, and then it performs the rest of the steps in the calling function. Okay, so in general, nested functions also exist, where one function can call another function, and that function can call another function, and another function can call another function. So a function within another function is called a nested function. This is what I am explaining in an extra. And then finally all the functions are called by the main function. Okay, and the main function is called by the operating system, where the output, where the execution takes place and the return value is being shown in the operating system. Okay, moving on. We have global variables and local variables. So what are global variables? Global variables are declared outside the function, usually at the top of the program, and are accessible by all the functions in the program while existing for the entire lifetime of the program. So global variables are alive throughout the program. You can just defining, just like macros, we have defined a particular value to and constant declaration. So global variable has a similar function. If you declare a particular global variable as 10, like pi equals to 3.14, you have declared it. So you can use the value of pi throughout the program. It won't be dead. in all the functions you can use in the even in the main function. Okay, so basically it is like this little guy, which is a global variable. You can consider it. This is a fun example. Okay, and local variables are inside a function or a block, are accessible only within the function or the block where they are created when the function is called and destroyed when the function is end. So this little guy can be considered as a local variable. So I think it is very fun to understand. This is global and this is local. Okay, so coming to an important point, if a global variable and local variable has the same name inside a particular function, like max equals to something, and then inside a particular function you have taken max as a different value, so that particular function, the maximum value which you have considered as the local variable will have higher precedence compared to the global variable inside that particular function only. When the function is exited, the value of global variable will be considered back again. Okay, if this happens only when the two variables have same name, the local and the global variable. So the local variable will have a higher precedence local to that particular block. Okay, moving on. We have an example with a code for global variable and local variable. Here the global variable is global var, which is equals to 100, and void display is a particular function for to display an int local variable. We are declaring it as 20, and then printing the global variable is being printed as 100 and local variable is being printed as 10. This is the output. And in main function, int local variable equals to 10, and printing the function. So after we call the display function, we are getting it as 20, right? In display function, global variable is 10, local variable is 20, and in main function, global variable is 100 and local variable is 10. I hope this makes it clear. Moving on, we have recursive function. Recursive function is very fun to understand actually, because recursive function is a function which will call itself within itself. Okay, you're calling itself within itself. So a function is calling itself. A recursive function is a function that calls itself directly or indirectly to solve a problem. It works by breaking a big problem into smaller problems until reaching a base case. So recursive function has two parts mainly. One is the base case and the second is the recursive case. Base case stops the recursion. Okay, and the recursive case is the function which keeps on calling itself and repeating, calling itself with a smaller input. Okay, so here we have the most famous example for factorial of a number, and let us understand this. In this we have one function which is factorial, where it receives one argument which is n of integer data type. Now we are checking it with the if condition, which is the base case. If n equals to 0 or n equal to 1, we have to return 1. Otherwise we will come to the recursive case. This will keep on calling itself. So return n into factorial of n minus 1. So inside this function factorial, we are calling this function again in the return statement. While exiting the function, we are calling the function again. Okay, this inside this function only we are calling it again. So that's why it is called recursive function. Okay, n into, so this is n into factorial of n minus 1. Whatever the value of n minus 1. Right? I think it is very interesting to understand. Now inside the main function, we are taking the number as 5 and printing the number, and here we are calling the function. Num is 5. Here 5 will be printed. Factorial of 5 is factorial of num. So here we are calling the function. So the value of num will be copied to n. So the num variable is passed to n. So the num value is declared as initialized as 5. So 5 is passed to this function factorial, and then it executes the program. And then we come to the main function and it is ended. So I hope the recursive function is clear and it is very interesting as well. Moving on, we have call by value and call by reference. So these are two basic things. A copy of an actual argument is passed to the function in call by value. It changes inside the function Changes are made inside the function and do not affect the original variable. Only works on local copies. Okay? And now we have call by reference. Call by reference, the address or the reference of the actual argument is passed, and changes inside the function do affect the original variable. Uses pointers. Now let us see an example and understand call by value and call by reference. So here is the example. We have one for call by value. We have one function which is change, which is having an argument as x, and we are calculating x equals to x plus 10. This is changes the local copy, and in int a equals to 5, and then change a. So a is being passed to this function, and now we are printing it. Output is printed as 5 and return. Okay. So since the changing of local variable is taking place, this is called call by value. Now call by reference, void change, int we are taking a pointer as x. Now pointer x equals to pointer x plus 10 changes the value at the address. So this is the value itself is changing in call by value. In call by reference, the address value is changing. Okay. So in main we are taking it as 5, and change, this is address of a, we are accessing the address of a here and calling the function change. Then we are printing it, and the output is printed as 15. So here 5 plus 15, the address at address level it is changing, and then it is printing the output. Here only 5 is being printed. I hope you get the difference. Now we are coming to the fourth unit, that is structures and unions. This is again a very important unit. Coming to the second last unit, that is structures and unions. This chapter we will cover the concepts of structures and unions, which includes the following topics. We will include the introduction, structure definition, structure declaration and initialization, operations on structure variables, arrays of structures, nested structures, structure pointers and unions in C. Okay, I hope this chapter will be super fun. So let us begin. A structure in C language. Okay, a structure in C is a user defined data type that groups different types of variables called members under a single name. It allows you to combine related data like an int, float and char into one unit, which is especially useful while modeling real world entities. So a structure is used to combine different groups of variables, different types of data types as a single unit. Is to use to group different types of data types in a single unit. But an array is used for what? An array is used to group the data of a particular data type. Okay, here data types are different. There's only one single data type, all types, same types of data. Okay, let's move on. We have the dot operator. So dot operator in structure plays an important role, okay, as it is used to access the members of the structure when you have a structure variable. We need to access it with the help of dot operator. So it is very important. It helps you retrieve and assign values to specific elements inside a structure. Moving on. Structure usage example. This is the example, and how to access the elements using a dot operator also we'll see here. So how we define a structure for a student. Now struct student, within the structure block we are defining one int variable, one character array, one string and one float variable. Okay, and then we close the structure and end it with a semicolon. This is the format of structure definition. Okay, then we come to the main function. Now we are assigning the this is for structure declaration. Now we are initializing the values to this structure student. Okay, so this is a keyword. This is a student. Student is a structure which consists of so many data types, right? And this order is followed, remember. So now this is a user defined data type, and now this is a variable. S1 is a variable. Okay, student is a data type of struct. Okay, struct student S. S1 is a data type of student structure. Okay, remember that. And now 101 is what? Integer roll number. Then we have char name. Then we are entering the name, and then we are entering the marks. Okay, this is how we initialize the members into a structure. Okay. But so that's why I told you the order of the mentioned data types should be the same. Should not be overlooked. Now we print it. Roll number percentage D, since it is declared as int, and comma S1 dot roll number. So S1, this one S1 dot roll number. At roll number 101 is being printed. Okay, so that's how we access it. And here name percentage S, S1 dot name. Here again percentage point to F, S1 dot marks. Okay, and this is the output. Here it is 101 is being printed, name, then Alice is being printed, marks, this is being printed. Okay, so defined using the struct keyword. These are the key points. Access the member using the dot operator and can store multiple records using an array of structures. Okay, moving on. We have structure declaration. I think you understood with the help of this example only, but still let's cover this topic. Declares a blueprint template of the structure, uses the struct keyword. So we use the struct keyword, structure name, and within the block we declare different types of data types as members. Here struct student in roll number char 50 marks, just like this example before. Moving on, we have structure definition and structure initialization. Structure definition defines the structure variables where after declaration. Okay, struct student S1 comma S2. This creates two variables S1 and S2 of type struct student. I just told you, right? Struct student is a data type. It is a new data type which you have created. It is user defined data type, and S1 and S2 are variables. There are two variables you have taken. So now after you have taken the variables, what will you do? You will initialize the values in the variables. So now coming to structure initialization. Assigning the values when declaring the structure variables. Syntax: struct student S1 comma equals to 101 Alice 95.5. So this is the roll number, name, and marks. And after initialization we need to print. So how do we print it? Using the dot operator. Printf percentage D S1 dot roll number. S1 dot operator we are using, and then we are using it as the structure variable. And here again percentage S S1 dot name. I hope I made it clear. If you would have looked at the example I had given here properly, then you would understand this is declaration part, this is the definition part and initialization part, right? And then this is the accessing part. So everything I have explained step by step. I hope it makes you clear. Now we have operations on structures. Let's see what operations we can perform on structures. Number one, accessing the members. We just did that, right? Using the dot operator to access and modify individual members, right? Struct student S1 dot roll number equals to this, and we are printing this, right? S1 dot roll number. Accessing one structure to another. Assigning one structure to another. You can directly assign one structure variable to another if they are of the same type. Okay. So struct student. Let's see with an example. Struct student S1 equals to 101 Alice 90. So struct student S2. So S2 equals to S1. So the value of S2 will be as same as the value of S1. So you don't need to write it again. We are assigning the value of S2 to another structure, that is S1. You don't have to. This is an operation which you can perform. Third type, using array of structures. You can create array of structure variables to store multiple records. So struct student S5. So you don't have to like create S1, S2, S3, S4, S5. You don't have to create. Already 5 variables of structure will be created on its own. So 5 times you can initialize different types of values or the same types of values if you want, according to the need of the program. Moving on, there is another operation by passing the structures to a function. You can pass the whole structure call by value, or we can pass the pointer to the structure call by reference. Just as we did in the functions, we have call by value for structures and reference as well. So void display struct student s, void display struct student pointer s. This is returns the address of the value. Pointer to structures, use the pointers with the arrow operator to access the variables. This consists of dash and greater than symbol. This is basically demonstrates a pointer to access the elements. So struct student address of pointer p, which is equals to address of s1. Whatever is stored in s1 will be accessed, and then when we print it, then pointer arrow roll number. It is similar to the dot operator, but since we are using a pointer here, we use the arrow to access a pointer. Moving on, we have arrays of structures in C. An array of structures lets you store multiple records, each with multiple fields together using one array. It's useful for things like lists of students, employee books, etc. So let's understand the array of structures with the help of an example. So in this example, we can see that we have a structure of student, int roll, character name, float marks, just as the same program before. So I think this is the declaration of the structure, and then inside the main function, we have created a structure variable, so an array of structure, which is this is student struct is the data type, and S3 there are three an array we have created. So for int I equals 0, I less than 3, I plus plus. Okay, so we are taking a for loop from 0 to less than 3, 0, 1, 2. So 3 times it is going to run. Inside the loop we have the print statement and scanf to access the roll number. Okay, so address of s at I dot roll number. Address of s, which is this one, address of s at ith position is what? 0. At 0th position we are taking what? Dot roll number. This thing we are taking. I think you will understand the scanf statement better, because address of s, this is what? The declaration of s. So address of s at which position? ith position. 0th position. Dot what are we accessing? What is this s? Roll number. So dot roll number. Okay, next we are printing the name. So again we are accessing the name with what? Percentage %d, since it is a string. And then for strings we don't use the address of operator, the ampersand symbol, because it is already, an array is already considered as a pointer. We don't need address of operator to access it. So s of I at what position? 0th position. The name is being accessed. Okay, this we are taking it as user input. Now again marks percentage %f, address of x s at I 0th position, what? Marks. Okay, this we are taking it as input. So this whole loop will take 3 values of name, 3 values of roll number, and 3 values of marks. Okay, and then we will finally print the details with using another loop. Okay, it's the same way again. Roll number, name, marks, roll number s dot I, roll number s dot I, name s dot I, marks. So, and yeah, this is the syntax. I think I just explained the program, and the syntax is this side. It should have been the opposite, but whatever. Moving on, we have nested structures. Nested structures is again nested in anything about programming, means something within another thing. So again, pregnant structures. A nested structure is a structure which contains one structure within another structure. This helps to model complex data where one entity has another grouped entity inside it, like a student having an address. Okay, so syntax is, this is struct inner. This is the inner structure which has data member 1, member 2, and then outer structure, data type of the outer member, and then struct inner member. From here we are accessing this inner member. So inside one structure, another structure is being present. So it's like calling a structure from another structure. We don't say that, we just call it nested structures. Now let us understand it with the help of a code. So this is one structure for date, day, month, year, as another structure for student, int, roll number, struct, date. So this is one structure. There is another structure. We are calling the structure from here to here. So it is not called structure call. This is called nested structure. From here we are taking a struct date DOB. We are producing this DOB is a variable of struct date. Okay, data type. Now in the main we are taking it as struct student s equals to initializing the structure. This is the first structure. This is the student structure. Here we are initializing the student structure s over here. So the roll number, only one entity is present here, and a structure within another structure. So within curly brackets we have another curly braces. So the DOB, this is DOB consists of what? 3 elements: date, month, year. So 15/8/2000. Okay, this is how we are initializing. I hope it makes it clear, right? Because roll number then DOB, so this is the order which is following, and DOB consists of what? Date, month, year. So this is a nested structure. We are accessing this with the help in the main program. So then this is how we are initializing it, a structure within another structure. Okay, so printf, we are printing it now. Okay, so s dot dob dot day. So s dot dob dot day, this we are printing. Okay, then we are printing s dot dob dot month, then we are printing 8, then we are printing s dot dob dot 8, we are printing 2000. Okay, I hope this is clear now. Moving on, we have structure pointers. This is the last topic of structures. A structure pointer is a pointer that stores the address of a structure variable. It allows you to efficiently access or modify structure members, especially when passing to functions. Okay, now let us look at the syntax. Struct name, structure name, data type. Member 1, data type, member 2. Struct structure name of pointer. Okay, so here we have created a pointer of struct structure name. We are creating the pointer which is pointing it to the structure only. Okay, this this is very useful for data structure and algorithms. Data structure and algorithm, it is really very important. Concept of structure pointers and structures is a very important for data structure, but we don't have data structure right now, so let's just understand the basics. So accessing members, we use the arrow operator to access members, or the dot operator. So these both are the same thing, pointer p dot member 1 or pointer at arrow. So this is basically the same thing. I hope it is clear. It won't be clear unless you do complex programs, but since we don't have it in our syllabus, it's fine. Let's look at the example. Inside a structure, student structure, we have created roll number, marks, and then inside main we have declared this and initialized it, the roll number and marks. Again, here this is a structure pointer. We have created pointer ptr, which is taking the address of s. Okay, so this pointer ptr is storing the address of s. Okay, this is pointing to this. Now access using a pointer. Printf, we are printing it as pointer ptr to roll number, or we can write it as pointer asterisk pointer within parenthesis dot roll number. This can also be done. Next we are printing it as marks, the same way. Modify using pointer. Since we are, let's see how to modify. Pointer marks 95.0. So we are changing the marks of 9.5 to 95.0. Now we print this s dot marks. Okay, moving on, we have unions. This is the comma. This marks the last part of the structures. A union in C is similar to a structure, but with a key difference. All the members in a union share the same memory location. This means that only one member of the union can store a value at any given time. The size of union is determined by the size of the largest member. Okay, so structures and unions are basically the same thing, but the memory location differs to a great extent. Just like I told you in the first chapter, we will be understanding it with the help of a diagram. Okay, so unions are the borrowed concepts from structures and therefore they follow the same syntax as structures. Okay, however, there's a major distinction between in them in terms of storage. In structures, each member has its own storage location, whereas all the members of a union use the same location. This implies that although union may contain many members of different types, it can handle only one member at a time. Okay? Like structures or union can be declared using the keyword union. Okay? So this is the syntax, union name, and then member 1 definition, member 2 definition, dot dot dot, n number of members we can declare, and then close it, and we use a semicolon. So about the memory location I was telling you. So we have suppose we have over here, let's look at this example only. Int float char. Int has what? 4 data types, 4 byte storage. Float has what? 4 byte storage, and char has what? 1 byte storage. So char will 1 byte will be saved as in this particular block, and 4 byte will be considered from name 1 2 3 4. It won't be saved as 4 separate blocks. Okay, for structures, if it is if these types of data types are declared, so it will be 4 plus 4 plus 1, 8 plus 1, 9 bytes will be stored for the whole thing as a structure. But here in union, only 4 bytes will be stored. 4 for int, 4 for float, and 1 for char. So this much will be char and this much will be float. I think you got it right. 4 bytes of memory will be allocated for union. So this much is 1 byte, this much is 2 byte ID marks, this much is 2 bytes, and this much is 4 bytes. So this one again till this one. Okay, short is considered as 2 bytes. So if one variable was considered as short, so name would be considered as 1 byte. Short will be considered as from here to here, these 2 bytes. Okay, but in structure would have been one is for 1 byte character and these two are for short. Next is for another type of data type. Okay, but in union we have this is for char, these two are for short. Again 4 bytes, 1 2 3 4 it is for int, and then if it is double, from here again name it will start until it will go till 8 bytes. I hope I made it clear, right? So it'll keep on repeating, so it'll handle one data type at a time. So the memory handling in unions is different. This is the only point of difference. Now let us understand with the unions with the help of an example. So union data, and inside the data this is the name of the union, and inside data we have 3 types of variables: int I, float f, and char c. Okay, in main we are taking union data d. So d is a variable of union data. Okay, so d at I equals to 10. We are assigning d at I equals to 10. This is declaration, this is initialization, and this is printing. Again d of f we are storing it as 3.14. We are printing this. D of c a, then we are printing this again. Notice only the last assigned member holds the valid data. You have to remember this. Now print after assigning dc di. We are printing this. These two which we are printing, it won't be printed properly. This is going to be stored as a garbage memory. Okay, I hope the concept of unions is clear. And now with this we come to the end of the 4th unit. Now we will be learning the 5th unit, which is the final unit in our syllabus. Moving on, we have pointers. This is the last and final chapter of our syllabus, and then we will be completed. I hope all the concepts will be super clear after the end of this chapter. So let's begin it with a full energy. So this chapter we will be covering the concept of pointers, which includes the following topics: introduction, declaration and initialization of pointer, just like all the other chapters. How to dereference a pointer, this is something new. Pointers and arrays, pointers and strings, pointer to a function. And last and foremost is the dynamic memory allocation, which is not very important right now because since we don't have data structures, but in general I'll explain what dynamic memory allocation is in brief. Moving on. Pointers in C language. A pointer in C language is a variable that stores the memory address of another variable. Okay? Instead of holding a direct value like int a equals to 5, it holds an address where the value will be stored. Access and modify the variables indirectly. Okay? Efficiently handle arrays and strings. Pass a large structure or arrays to functions without copying. Enable dynamic memory allocation, malloc free. These are the functions or declared under dynamic memory allocation, which we will be covering as the last topic. And work with data structures like linked list, trees, graph. So of course pointers mainly uses data structure, but we don't have that in syllabus. So we will just cover the general idea of pointers in this chapters, and we will end our syllabus. Now coming to pointer declaration. We declare a pointer by specifying the data type of pointers and using the symbol star. Okay, the syntax is data type star pointer name. Okay, and the example is int data pointer and this is the PTR pointer to int. Declare a pointer by specifying the data type to its points, and this is the syntax, and we understood with an example. Pointer initialization. You initialize a pointer by assigning it to the address of the existing variable using the address of operator, and this is the example. Int a equals to 10, int pointer ptr equals to address of a. Now ptr holds the address of a. Okay, moving on. We have dereferencing of a pointer. Dereferencing means accessing the value stored at the memory address of a pointer holds. You do that by using the asterisk operator. It is used to read the value at the pointed location to modify the value at the pointed location. So the example is int a equals to 0, address of pointer ptr equals to address of a. Okay, printf %t ptr pointer ptr. Dereferencing gives a value of 10. Okay, we give ptr pointing, it gives a value of 10. So explanation is ptr stores the address is stored in the pointer. Okay, and star ptr the value at that address. That is called dereferencing. Okay, I hope you understand it. Next is we'll understand it with the help of a code for pointer dereferencing. Hash include, and then inside the main function we have declared a variable x equals to 10, pointer p equals to address of x, which will point it at 20. Then we will print the variable which will print 20, and address of variable here we are printing it as p. This will print the address, and then pointer p, when we are printing, then it will print the dereferenced value which is 20. I hope you understood the difference between the two. So here it is going to print 20. Again, in the address, this address is going to be printed. The address is going to be printed because we haven't dereferenced with using the star operator. And next, we'll know how to modify the value. Pointer ptr equals to 50. So this value is changed from 20 to 50. Now the new value is going to be 50. So value via pointer is 20. So now the new value is 50. I hope you understand it. Next. Arrays and pointers. In C, pointers and arrays share a close relationship. An array name can often be used as if it were a pointer, and pointers can be used to access array elements. However, they are not entirely interchangeable. Okay. Similarities are, we will understand the similarities and differences between an array and a pointer. So array name like ARR acts as a constant pointer to its first element. So since the array acts as a constant pointer, when we need to use scanf to get input of the array elements, we don't use the address of operator, the ampersand symbol. We don't use, because it acts as a pointer to itself. So that's why I told you before, right? you can use a pointer arithmetic to access array elements. So this is the example. Int ARR 5, this is the array, and pointer PTR equals to ARR, which points to the array at first index, which is at 0, which is pointing it to 10. Now we are printing it %d ARR of 2. Okay, now let's understand the key differences. Coming to the key differences, which are pointers memory allocated for all elements, needs explicit allocation of assignment, name fixed, cannot be reassigned, it can point anywhere, reassigned, size of operator, we use the size of operator to check the size of any data type. Here the pointer, size of pointer, and decays of as a pointer, yes, in expressions already a pointer. So size of ARR prints a total array size, example 20 bytes if int 5. Okay, 5 into 4 equals to 20, because int has 4 data types, so 5 into 4 is 20. This is storing the list size of array ARR, this int, so it is storing it as 5. So address of size of PTR, pointer, example 8 bytes on 64-bit system. Okay, this point we are understanding. Even though you can use pointers to access array elements, the array element itself is not a modifiable pointer. You can't do ARR equals to other pointer. You cannot use it like this. This is not allowed in this example. PTR I equals to dereference PTR plus I equals to ARR of I. You cannot use it. Okay, because they are not modifiable. Moving on, we have an example for arrays and pointers. This is the example. So in the main function we have declared an array of size 5, and we have declared a pointer PTR which is of array points to the first element of ARR, which is pointing to the first element, which is 10. Using the array indexing, for now we are taking a loop from 0 to 5, less than 5, and which is will run from 0 to 4 at the fourth index, which is 50. Printf %d this I comma ARR of I. Okay, now printing using the pointers using arithmetic equation for int I equals to 0, I less than 5, I plus plus. Print using this statement, we are printing it, print the value of I and pointer PTR of I. Then we are printing the address of ARR, then we are printing the value, and then we are printing the size using the size of operator, which we just went through. So now the output is, for the first loop we are getting the output as ARR of 0 equals to 10, ARR of 1 equals to 20, ARR of 2 equals to 30, ARR of 3 equals to 40, ARR of 4 equals to 50. Using pointer arithmetic, after using the pointer arithmetic here in this loop, we are using pointer PTR plus 0 equals to 10, PTR plus 1 equals to 2, PTR plus 2 equals to 30, PTR plus 3 equals to 40, PTR plus 4 equals to 50. Okay, and addresses, when we are printing the addresses here in these two lines, this is the address of ARR is being printed, address of PTR is being printed. Okay, and for the sizes, ARR, size of ARR is being printed as 20 bytes, because 5 into int, size of int 5 into 4 is 20, and then next is size of PTR is being printed as 8 bytes, size of pointer only. Okay, so the key takeaways are ARR of I and pointer PTR I will give the same result. ARR holds the starting address, but you can't reassign it. ARR of size of ARR gives the total array size, size of PTR gives the pointer size. Okay, moving on, we have pointers and strings. In C, strings and arrays of characters ending with a null terminator. Since arrays and pointers are closely related, pointers can be used to handle strings efficiently. Two common ways to define strings is number as a character array as a pointer to a string literal. Char str equals to hello, this we understood, and now this is char pointer PTR equals to hello. Okay, why do we use pointers? To traverse or process strings efficiently, to pass the strings into functions without copying, to work with dynamic strings using malloc. Key features. Feature is memory. In character array allocated within writable memory. in pointer to string literal stored in read-only memory. Modification, character array, you can change the characters. For pointer to string literal, you should not modify the literal. Example, str1a, okay, and this is the example. Moving on, we have example for use of pointers with strings. This is the main function str1 hello, and string this is the second one world, and using ptr we are printing both of them. And now accessing the characters, first character we are accessing it as str of 0, which is h is being printed here, hello world is being printed, first character of array h is being printed, first character of pointer str2 at pointer, using the pointer string literal operation, and then we are printing the pointer w here. And then pointer traversal means visiting every element of the pointer. So now again we are using a loop, pointer str I plus 1 is not equal to 0, we are checking it the condition, and then we are going inside the loop, and then we are printing the pointer. So at the pointer value, this world is going to be printed one after another, and then the new line. This is going to be the output. I hope it is clear. Next, moving on, we have pointer to a function. A function pointer in C is a pointer that points the address of a function. This lets you call a function through the pointer, pass it as an argument, or return it from another function. Declaration of a function, declaration syntax, return type, pointer name, and parameter types. Okay, so basic example is here we have an add, and then we return a plus b. I'm really sorry for this. Void main, and then in this function we declare the pointer, and then for function equals to we assign the address of the pointer, and then now we call the function, and then we print it. So the output is resulting as 8. Now we call passing the function pointer to another function. Now we are passing this function to another function, void call function. In this we are taking the function and taking two arguments. Result is we are taking it, and now int multiply, we are taking a multiply function, and then in the main function we are calling the function call fang, and then you are passing this function inside the call function. So now the result we will get it as 24. Dynamic memory allocation. This is the last part of the last chapter. Okay. Dynamic memory allocation is a process of allocating memory at runtime when the program is running, rather than at compile time, like with regular arrays or variables. This gives you the flexibility to request exactly the amount of memory you need, especially useful when the size isn't known in advance on your data. Generally, in small and simple programs, pointers are rarely used except for passing the arguments for reference to the pointers. After all, we have the option to access the memory of a variable by itself, right? But so why should we use the address to access the variable? Pointers find more beneficial use in addressing dynamic objects created at runtime. We don't have the option to name any dynamically created variables at runtime, but we have the access to we can access them by their address by using pointers. In C program runs, when a C program runs, it has access to a relatively large area of unused free memory called the heap. We can make use of this memory free memory to create memory variables to store runtime data of our program. That is otherwise not possible to determine at the time of writing the code for our program. For example, suppose we are writing a C program to sort a list of blood donors in alphabetical order of their place of living who will participate in blood donation camp. Now we can't say exactly how many people will show up for the blood donation on any particular day. Hence we cannot determine the amount of memory variable we shall need to handle in such an undetermined list. So what we can do here is we can create a pointer variable of the list type. We shall need and leave the task for allocating memory for the list for runtime. At runtime, the program shall allocate memory as required from the free memory pool and assign the address of the allocated memory to the list pointer. The list pointer will then become our gateway to that free memory reserved for our runtime list. After we are done with our runtime list, we must also return the dynamically reserved memory to the free memory pool so that it can be reused from some other purpose. Okay, I think you understood the difference now, right? So to allocate a block of dynamic memory from the heap, the C library provides us with some useful library functions. Now we will be learning about the functions. First of them, it is malloc, which uses uninitialized memory block. Calloc, which allocates the zero initialized memory block. Realloc resizes the previously allocated memory, and free allocates the memory to avoid memory leaks. Okay, so malloc is used to allocate memory from the heap. There's another function called calloc which is used to use the same purpose. The function free, which is used to release the memory address by malloc and calloc and return it to the heap. We will see the syntax. We will not see the syntax right now. We will just use it directly in the code. And here is a code. So dynamic memory allocation. For dynamic memory allocation, it is not defined under stdio.h header file. It is defined under the stdlib header file. stdlib. In main function, we are declaring it as a pointer, and with this pointer only, we are taking as the int pointer malloc. Malloc is the function we are using. 5 pointer size of int allocates the space for 5 integers. Okay, if ptr pointer equals to none, if we have to checking that the pointer is null or not, okay, then the memory allocation failed. Return 1. Okay, now we have to use the memory. For int I equals to 0, I less than 5, I plus plus. ptr pointer I, which is equals to at 0, 0 into 10, and then again in another loop we have taking I equals to 0, I less than 5, I plus plus. We are printing it. This is the use of memory, and this is for the printing. And after it is done, after the printing is done, we need to free ptr, otherwise it will cause junk and garbage and we cannot be using the heap memory again. Okay, so the output will be 0, 10, 20, 30, 40. Okay, now dynamic memory allocation allows flexible and efficient use of memory at runtime, but you must manually free the memory when done to avoid memory leaks. Okay, with this we come to the end of the 5th unit, and dynamic memory allocation is completed. I hope all the concepts are crystal clear. Every topic and every chapter is crystal clear, and every topic I've tried to cover it within 3 hours. So I hope every topic is clear, and thank you for watching. Thank you for understanding. And this is Rohini Sengupta. Finally, I am signing out. So goodbye. Thank you, and thank you very much for watching. Bye bye.